workshop on how to deploy an app onto our network. I guess I'll start off a little bit about Aleo. Aleo is a ZK Layer 1 project. Our main goal is making developing ZK apps easy, abstracting away a lot of the complicated math and cryptography that's required to understand circuits and things of that nature. So we're going to jump pretty much right into the workshop. Usually I'd give a bunch of slides and kind of talk a little bit about our programming language. So instead, I don't have time for that today, so instead I'm going to point you to the docs. So I would recommend checking out aleo.org, but more importantly, if you're hacking with Aleo this week, developer.aleo.org. This is kind of all of our documentation, the home of everything. This is where you'll be able to answer your own questions. Also recommend checking out our Discord, which you can find links to from the main site, aleo.org. If you scroll down, you'll find links to Discord, Twitter, YouTube, etc. There's a large community of over 200,000 people building on Aleo that you can check out. Shout out to Eugene, who is very helpful in managing that community. So with that, we're just going to jump right into it. If you want to follow along, you can. You could just watch me and follow along and do this on your own time afterwards. We do have a $100 incentive if you successfully deploy an app. So that's like a quick way to earn $100. Walk away from the hackathon a winner, even if you don't win any other bounty. I'm just gonna run through this. It's super easy. The nice thing is, regardless of how complex your app is, deployment doesn't really change. So once you kind of have this down, you won't ever have to learn how to do it again. There's some software you have to install, Git, of course, Rust. The whole stack that we use is open source and it's all built on Rust. Highly recommend if you're a Rust developer, you go check it out, contribute, etc. So then the most important things you have to install here are our Leo programming language, which is a high-level language. It looks a little bit like TypeScript or Rust, and it compiles ultimately down into ZK circuits. If you're curious about that, you can read the docs or come and find me after this talk, and we can talk a little bit more about that. You also want to install SnarkOS. There's some instructions on how to do that. If you're on a Windows machine, please go check out this FAQ, and I have some instructions. You need to install LLVM and some other prerequisites in order to get that installation to work, and it can be kind of a pain. If you're on Mac, don't worry about it. Everything will work smoothly, I promise. I would also recommend you install the Leo wallet. It looks a little something like this. It's a Chrome extension. You'll be using it in the tutorial, and it's also the easiest way to interact with your account and records on chain. So let's get into it. I'm going to be using VS Code for everything that I do today. You can use whatever editor you want. We have Leo plugins for most of the major editors out there, including Sublime, IntelliJ, VS Code, etc. All right, so I have the repo cloned here. You'll see a file structure that looks a little something like this. I'm just going to make this bigger for you guys. This is the private key to my workshop wallet. If you want to steal my tokens, be my guest. We are in testnet right now. We are looking to launch mainnet sometime in December, so definitely look out for that. In the meantime, check out the network, deploy an app, try to build something. Where we encourage anybody building stuff who's interested in doing ZK. So first and foremost, I'll introduce Leo. Normally, I'd spend quite a bit of time talking about our programming language before getting into this demo, but I don't have time for that today, so I'm just going to jump right into it. This probably looks pretty familiar to you. Like I said, if you've used TypeScript, if you've used Rust, this is a function type called a transition. One important thing to note about Aleo, and kind of one of the reasons why we decided to go with a layer 1 instead of building an EVM-based layer 2, is we have a different infrastructure setup than most of than the EVM. Primarily, there's two infrastructure players. We have validators, which validate things like you're probably used to, but we also have another infrastructure layer called a prover, And the main goal of provers is to execute transactions off-chain, roll them up into a proof, and submit them to validators. What this enables is quite a few useful things. One is that we have fixed gas prices, so you're not paying a congestion fee in order to fight for block space. That's not something that exists, in our paradigm. So a read always costs what a read costs, and a write always costs what a write costs. Also, because of this, we have privacy by default. So you actually have to explicitly mark a variable as public. And so transition functions, primarily the main point there is anything in a transition function is going to be executed by a prover. There's also another function type that I can show you. I'm going to jump into the playground here, and we're going to show you a token example real quick, just to show off a finalize function. So if you're doing public things, finalize functions are executed by validators, and that is the way to handle public state. Typically, you'd use a mapping. Mappings work like any other hash map or some similar data structures that you might be used to. The key difference here is that mappings are on-chain state. So you can use those to look up anything that you want to be public. And anything that is not public, you would deal with a record type. Records have an owner, they're encrypted, and they can only be decrypted by whatever whatever private key has encrypted them on-chain. Highly recommend checking out the playground if you want to see some more complete examples than what I'll be able to get through today. That's at play.leo-lang.org. And you can also find this information on the main website as well by going aleo.org. And if you go to build, there's links to all of the stuff that I'm mentioning, as well as our grants program, which is something that my team runs. If you're interested in building and getting a grant to build, definitely come talk to me, and we can talk about your idea. So with that, back to the workshop. How do we deploy an app on the network? So first, we've installed all of our software. We need to create a new wallet. Two ways to do that. There's a CLI that you can use to do that, or you can use the Leo wallet extension like I showed you here. You'll follow a typical seed phrase setup process, and you'll have a wallet. And then you can use our faucet to get some tokens. The faucet will prompt you with a QR code. You scan it, you send a text to our faucet bot, and it'll send you some tokens. If you don't have a US phone number, currently we're using Twilio, which is pretty limited as far as what countries that they've implemented. Just come and find me, and I'll get you some tokens so you can follow along with the demo. So jumping back into it, first thing we're going to do is initialize our project. So we can do that by running leo new. And in this case, we have this weird random string here so that our project name is unique. The global package manager requires a unique project ID. So this is just a way for me to increase the likelihood that we have. So I'm going to go leo new. I'm just going to paste this in here. Have a new project. Cool. You'll see our directory looks like this. And then we can write our program. I've provided a very, very basic token example here. You can just copy paste this and check it out. Like I said, check out the examples for more complicated code or for more syntax examples and kind of more of the language features. We're really just focused on how to deploy today. So I'm just going to go ahead and open up that new directory that I just created because I personally prefer working in VS Code. And we have 3 different types of files here that are important. One is our main file. So this is kind of the Hello World app for Aleo. We can build it, and it'll output an intermediate representation called .aleo. This looks like any assembly language that you've probably seen. The reason why this exists is because we're not executing on an x86 execution environment or even an EVM execution environment. We're compiling down into circuits, which is kind of a new execution paradigm. So in order to abstract all of that complicated detail away, we've had to completely build language from scratch. You've probably heard of other projects like Noir or Aztec. Or Circom is another example of this kind of thing. So let's take our token example, and we're going to paste it into here. I'm going to build it. Looks like we have an error. Right. So the last file that I did not talk about is an input file. In a ZK circuit, they're deterministic, and so you actually need to, in order to build your circuit, you need to have your input. And with that, the way that we currently provide inputs to programs, at least locally, is with this input file. And so I have an example of this input file here that you can copy. And then we should be able to build our program. Looks like I'm missing a semicolon, or I have an extra one. Cool. So now if we went back to our instructions, we can see that our two functions that we just defined are here. We have a mint function, which is fairly straightforward. We take this token record and we return it, which will, if we run it, Leo run mint, we'll see that it outputs. On chain, this would be encrypted. Because I'm running everything locally with my own private key, there's, of course, I can see what's going on here. And so if we wanted to transfer a token to another address, one important thing to note about Aleo is that we don't work on the account model. You might have heard of UTXO. We have a model that's more similar to UTXO called the record model. And so in order to execute a transaction, you need to spend a record, which means you need to input a record to a transaction, which would typically output a record as well. There is also a default record type on the network that I will show you in a few minutes once we get to the deploy example. So we want to run transfer, right? We want to simulate transferring, from the tokens we just minted, this record, to another wallet. And so I'm going to take this token record that we just output in the console and paste it in here. We have to remove these suffixes. That's just kind of an annoyance right now. It's not an important detail. And so with that, we can run a transfer function. And if we look at our transfer function before we run it, you'll see we actually output a tuple of records, right? So we calculate the new balance. We create a record for the recipient and the transfer amount that we're interested in. And we also need to make a new record because we're spending the existing one that the sender is providing, where the tokens are. So if we run this, we'll see we have an output. Our program works. We've transferred 10 tokens to this address, and the original sender now only has 90 tokens. So that was this part here, build and test. Just kind of an example to show you how you can run and build and work on programs. And so I mentioned the record, right? If we want to submit a deploy transaction, we need to pay for it, and we need to spend a record to do that. One easy way to get a record is to go into your Leo wallet and check out your most recent activity. So this is a transaction that I made a couple weeks ago to put some credits into this wallet. We jump into the output of this transition, and one important thing to note is that this is completely encrypted. You see this ciphertext here. If you are some other user, you can't see what happened in this transaction. But because I own this record, I can connect my wallet, I can decrypt it, and I can get the record plaintext. And this is what I'm going to be using to tell the deploy program, what record am I talking about? Let me make this bigger for you guys. What record am I talking about? How many credits are in this record to be spent? And a nonce as well. So I'm going to create a deploy.sh file just to keep things nice and repeatable. So I'm going to copy this long command, which this is a deploy command here. SnarkOS is a utility that you'll install following through this workshop, and provides a bunch of CLI utilities to interact with the chain as well. If you want to run a node or a prover, you'd use SnarkOS to do that. So we're going to grab that private key that I said you can steal from earlier. I'm going to paste that in here. I'm going to take my project name, which is going to be my package name on chain, and we're going to run this. and I forgot something. So that record that I mentioned was super important. I forgot that. So let's go and grab that real quick. Cool. So we'll run this deployment. I'm fairly confident that it'll go through successfully, and then we could check out our program in Explorer once we have our transition ID. Oh, input record must belong to signer. So let's, usually this happens, this error message is not super descriptive. Usually this happens when the private key is not the same as the one that we're trying to send. So let's get this private key real quick and just double verify. It was wrong. And so now that our private key is correct, and so you saw here that if you tried to spend a record that wasn't yours, it just doesn't work. You can't decrypt it, so you can't use it. One sec. I'm gonna leave some time for questions at the end. Yeah. We'll be done in about a minute once this finishes. Thanks. There's a couple explorers out there. This is one. It's open source. This very wonderful community contributor named Haruka. Big shout out to him. Just built this on his own. We tried to give him money. He didn't want any. Yeah, guy's kind of awesome. There's another one out there called alio123.io. It's a little newer. It's a little fancier. Like it has a kind of a prettier UI. They both have some differences in features. So if we go back to our deployment, you'll see it was successful. We can take this transaction ID and check it out in the Explorer. And we'll see our program here was successfully deployed. And actually, we can jump into our program and see our source code on chain. So we just privately deployed an app that implements a very basic private token with private minting and private transfers, all in 17 minutes or so. And so that's it for the workshop. Super quick, super fast. Please come to me with any questions. I'm going to take some questions that we have time for, and then I'll be available afterwards for one-on-one. There's a bunch of APIs available, as well as command line utilities and a JavaScript SDK. You'll find more information about that on the docs, and if you check out our GitHub repositories. And so one thing I do want to point out is that if you follow through with this workshop and you successfully deploy, you can submit and check out this QR code here, which I'm working on sending to everyone. You can earn $100 just for deploying this very simple program. As you saw, it took me about 10 minutes. So probably the fastest $100 you'll earn this weekend. We have another question, I think. Yeah. Yeah. So we definitely we do that. Yeah. So the question was about detecting underflow, arithmetic underflows and overflows is quite difficult in a ZK circuit environment. And he asked, how are we doing that? My answer might not be the one you're looking for. I actually don't know the exact details. I know that we do that because I've written a program that has the capability for an overflow. And so I think it's actually checked at the compiler level. If there's any code that can result in an overflow or underflow, you can't compile the program at all. That's my current understanding. When you try to execute it with a certain set of inputs, it'll warn you. Correct. That's how it works currently. The language is under development, of course. So if that's something that you feel is a bad developer experience, I'd highly recommend submitting an issue or creating a discussion in the community. Yeah. Last question. So the proving system we're using is based off of Marlin. It's a snark-based system. I don't have time to answer this exact question, but you can find more information in the docs. That's where I'd point you first. And I can also connect you with people who know a little bit more about the deep internals of the cryptography, if you're interested. Cool. Well, thank you very much, everybody. Really appreciate your time.
Can you all hear me? Awesome. My name is Julien Genessu. I'm the CEO and founder at Unlock Protocol. And today I'm going to show you, make a quick introduction of what Unlock is. And then if we have enough time, we'll do a live coding session. Usually go very fast, but I'll point to the GitHub as well so you can use this. So first, quick agenda, Unlock Protocol overview. Then we'll jump into some dev tools, all of our ecosystem of tools. Then how to add Unlock to a front-end use case. And again, that's the live coding session. Then more about smart contracts, about hooks, about UI. And finally, a bunch of links that you can use for your hacks tonight, tomorrow, and obviously, hopefully you'll win the hackathon on Sunday. Somebody is very kindly distributing a little leaflet with QR codes on this, with links to the docs, etc. So please use that. My name is Julien. I am the CEO and founder at Unlock Protocol. I am French. Prior to Unlock, I was the founder of a company called Superfeeder, which was sold to Medium, the blogging platform. I still think people know what Medium is. In 2016, I'm a big open source fan. I worked with W3C, World Wide Web Consortium. People don't know what it is usually in that space, but that's basically people that actually normalize or write the spec of how the internet should work. It's fun, but it's annoying. And I'm also a member of the Graph Council, which is their kind of DAO governance thing. You can find me as Julian51 on all of the things. Yes, all of the prior 50s were taken. Or use my blog at ouvre-boîte.com, which is token gated, by the way. And if you get a membership to read some of my posts, it's $5 a year. It's cheap. Let me know, and then I'll pay coffee when we meet in person. What is Unlock Protocol? Unlock Protocol is a protocol for memberships. Simply speaking, it's a system to create membership and sell access NFTs in minutes within your apps, within your content, etc., etc. It is used for memberships like a gym membership, a club membership. It's used for subscription, like your Netflix account could be, should be, will eventually be an NFT. It can be used for ticketing. A ticket to a conference, a ticket to an event is an NFT that gives you access to physical space. It's used for what we call token gating, and that's what we'll see in a couple of minutes. But also for things like certification. Your degrees, your driving license should be NFTs that have an expiration date, or maybe not, actually your diploma is forever, but your driving license expires every 5 years, I think, in the US. I should know this because I have one. But also it can be used for gaming. So for example, you can unlock a certain level that you can access for a day, a week, a month, etc., etc. It is obviously fully open source, so all of the code that we've ever written at Unlock is open and ready for your inspection, I guess. It's also community governed. We have a DAO with people that are participating and contributing new code, new updates every day at this point. A bunch of apps, a bunch of libraries, and a bunch of dev tools, and then we'll go into that in a couple of minutes. We have a pretty diverse team of people, again, me, but also people from Google, Facebook, the evil people, from GoDaddy, and a bunch of other organizations. So wait, I talked about NFT membership. Any NFT could work? Well, no, because most NFTs were not built to be memberships. They are built to be collectibles. And so, for example, they're perpetual. If you're a business and you sell regular NFTs to make revenue, well, I've got some good news. You're going to make some money maybe on the first couple days, but then you will never, ever sell more NFTs. You can hope on royalties, but as we hopefully by now all know, royalties are a lie. They actually are not enforceable. So there is no way your business can make money on an ongoing, recurring way. Well, that's why we've created kind of a new kind of NFTs. They're ERC 721 that have an expiration date to allow to have kind of time-bound NFTs. So NFTs that are valid only for a certain time. That allows you to do, for example, recurring revenue, where you can say, okay, the NFTs expire every month unless the user, the owner of the NFT, pays a bit more every month. And again, Netflix account, that's how they work. Basically, you pay every month. I think now it's almost $15, but you pay $10 a month for it to be renewed and extended for another month. And when you stop paying, well, the account actually expires. It is also, Unlock has been built so that it can support multiple payment mechanisms. Obviously, crypto payments. So native currencies on all of the chain that we're deployed on. At this point, it's on 12 different EVM networks. We'll talk about this in a couple of minutes. But also you can use any ERC20 token. So you can say, hey, I actually don't want to be paid in Matic or in ETH because these are fluctuating currencies. I'd rather be paid in USDC, in DAI, in EuroC, in any ERC20. That is absolutely possible. It has a mechanism to do on-chain verification. That's the normal NFT verification. But also off-chain, where we have a mechanism for owners of an NFT to sign it and provide that signature in the form of a QR code, for example, that anyone can scan to verify that indeed the owner of the NFT signed and still owns the NFT. They can be made transferable or non-transferable, as we call them, soul-bound in that space. But I think more importantly, they can also be programmatically transferable. So maybe allow transfers if the user does something or unless something else is true. And obviously we go from a model where all of the NFT contracts are immutable. They're put out there, and if there's any issue in them, well, too bad, they're there forever, to something that becomes programmable or upgradable in a way that allows developers like yourself change the behavior of the contract. So you might say, okay, at first I will not allow refunds, but maybe after a couple of years, I will allow refunds. And it is possible to keep the same contract without having to remint everything and say, hey, these NFTs, initially they were not refundable, now they are refundable. So far, so good? So Unlock, I was just alluding to this a couple seconds, updatable. You can change all of the properties of the membership contract, so including the price, including the duration. You go from maybe a month-long membership to something that is a quarterly-based membership. You can change the price from something that is like $5 a month to $7 a month, Netflix. You can go from a limited supply to a larger supply. You can go from having only one manager for the contract to multiple managers, which could be apps that can change how these memberships work, et cetera, et cetera, et cetera. They're also, as I said, upgradable. So the protocol itself is on, I think, version 11. I should know this as well, but we're just about to move to a new version. And that means that when the protocol adds new features, maybe support for things that it didn't have earlier, you can decide to opt in for these new features of the protocol. You cannot upgrade to a random version, otherwise it doesn't become standard anymore. You can only upgrade to versions that have been community approved by the DAO. And finally, and maybe this is one of the interesting part for you guys, the smart contracts themselves are programmable through the concept of hooks. So you can change how the contract behaves based on some custom logic. So for example, one thing that people always ask is like, hey, can I do something where maybe the price of the NFTs change based on how many have been sold? And you can actually absolutely do that with the hooks. So you can have a system where maybe the price at first is 1 USDC, and then every time somebody buys, you double that. And so obviously that's going to get very expensive very quickly in a programmatic way, so you don't actually have to go manually poke the contract to change the contract. Somebody buys, price goes up, somebody buys, price goes up, etc., etc. Key use cases. Event ticketing. So there's been a ton of events that I've used Unlock for ticketing, including actually some ETHGlobal hackathon a few years back. Recurring subscriptions, or actually ETHCC as well if you guys were in Paris. I know ETH Mexico, ETH Vietnam, happening in the next couple of weeks, are using Unlock for ticketing. You can do recurring subscription. I mentioned, Netflix, but there's many at this point. I'd say a good 20 different websites that are using Unlock for monetizing blogs or video content in a recurring way. So you pay every month, and your NFT gets extended, and you can get keep access. Time-based membership. We have seen a few DAOs use Unlock for this, where they have a seasonal approach, where we say, okay, these membership are valid for 3 months. At the end of the 3 months, they expire and they're not automatically renewed, but that's kind of seasons to make sure that the DAO has active memberships. We have certification and credentials. So we have a company that is using Unlock to recertify its financial advisors every year. So basically, they give them an NFT if they cannot transfer. Obviously, they give them an NFT that shows that they've been certified, and at the end of the year, it expires unless the person who was certified actually recertifies by going through, some online presentation, etc. Used for gaming as well. There has been a couple of games that have used Unlock for different things. So either unlocking levels or unlocking different capabilities for their players. Used also for loyalty. We have a platform called Chasm. I don't know if you guys have heard it, but they're building kind of loyalty program like your Starbucks kind of loyalty thing on top of Unlock, and that's another example. Attendance NFTs, sometimes called POAPs. People use Unlock for this. And also my least favorite category, the digital collectibles, the PFPs, and all of the NFT crap that hopefully is on the way out at this point. Let's go a bit deeper into a specific use case. So event ticketing, I mentioned a few conferences. What's interesting here is like 100% of what the crypto user, 100% of the crypto payment goes to the organizers, which is pretty cool. It is end-to-end ticket, so you're actually not buying through a platform, you're actually buying through the smart contract as an attendee. And then the organizers of the conference can decide whether they want to allow people to resell their tickets or not, which I think is pretty powerful. But you can also create, and for me that's the power of blockchain, interoperable experiences beyond just the event itself. So you can say, hey, maybe before the conference, anybody who has bought a ticket, they have an NFT. Well, you know what, I'm going to use Snapshot. You guys are familiar with Snapshot? Yes, no? Snapshot is a voting system, snapshot.org, pretty cool thing, off-chain voting, but you can make it so that only people that have a ticket to the conference can vote on what is going to be the food or who's going to be the main speaker, which I think is cool. You can also create maybe token-gated channels on Warpcast, Farcaster. People know Warp, Farcaster, maybe no, but social networks, and only participants, only attendees of the conference are able to participate, which I think is another cool example of how this membership goes beyond just hey, you only have a ticket to go attend the thing. Now you have an NFT that gives you access to many different things across the web. Sorry for hitting the mic here. Tickets act as a membership and card to connect with the community of people that have the same, obviously, NFTs in their wallets. Example, a couple weeks ago, DAppCon in Berlin. Actually, that was last weekend. Feels like forever. Nearly 1,000 attendees, all using Unlock for ticketing. I'll spare you some of the details, but yeah, basically, if you buy the NFT, you get a QR code as well, which you can show to the organizers and prove that you have a ticket. Also, people got swag through the NFT, which is really cool. Like the sponsors were able to airdrop other NFTs and a bunch of other things to the attendees of the conference, and knowing that they're only the attendees of the conference because they had the NFT that proved that they had a ticket. Another key use case of the protocol is subscription. So token-enabled experiences. I mentioned my blog a couple of minutes ago, but again, there's about 20 different websites that you do that at this point. And what's really interesting is like for these businesses, it creates ongoing recurring revenue. So think of like a Patreon or a Substack-like model where as a creator, instead of selling one-off things and then hope that I'm going to be able to sell more and more of these, I can just tell my fans, hey, you guys are interested in following my content. Why don't you pay every week, every month, every day to get some of that content? We support, as I said, both crypto and credit card. We have an integration with Stripe as well as an integration with Crossmint. which make this really easy. So direct relationship between the creators and the members. No way somebody can say, hey, your content is not good enough, or your content is too adult for my platform, I'll kick you out. No middlemen, and that applies to content, to software. Think of like in-app purchase. I'm sure you all have mobile phones. You might have in-app purchases in this. Well, they're currently records in a database either at Apple's or Google's servers. You can make them NFTs and say, hey, if the user has an NFT in their wallet, I'll show them, dark mode or whatever is the feature that I want to token gate or not inside of my app. So really kind of creating kind of permissionless app stores is a really cool idea here. Any question? No? So far so good? An example here, we have a community member. I mentioned one of these 20 guys, but I actually don't know if they're guys. DeFi Robots, they're providing trading tips via their Telegram bots. And you cannot access the Telegram groups unless you have one of their NFTs. They're fairly expensive NFTs, I think like something like $100, $200 a month or something like this. Or actually, $100 3 days and then $200 a month. But that's a cool example of using Unlock for that. I have 3 more minutes, so it's going to be really short. Time and membership. Let's keep that. Example, Cabin DAO. People know Cabin. Cabin is a kind of a club for people that are cool and want to hang out together in the forest. They're using Unlock for memberships. Definitely a very cool use case here. Going back to the key use cases. Ecosystem and tooling. So we have a dashboard, obviously a front end where you can use to deploy, inspect your contract, do a bunch of things. This is completely optional. Obviously, the front end itself is just a front end you can replace with your block explorer of choice or an application that you build yourself. You can use that to change the characteristics of your contract, as well as do some things like airdrop membership and others. I would definitely invite you to check that out if you get started. It's the easiest way. We also have a checkout UI, which is an easy way for people who don't want to build kind of the whole checkout flow. Say, hey, all right, cool, I want to enable credit card. I just check a bunch of boxes, and then users are going through that checkout UI. And as I said, we support multiple types of payment. We also have developer tooling. So subgraphs, hopefully you guys are familiar with subgraphs, but it's basically a way to aggregate a bunch of information coming from chains. We have a JavaScript library called Unlock.js. We have a paywall, which is actually that checkout UI that I just described, as well as hooks at the contract level. So we also have webhooks, but these are smart contract hooks that allow you to alter how the contracts behave. Multiple types of integration. Anything that works with an ES 721, which is one of these 2 NFT specifications, will work great with Unlock. So framework like Ethers, Third Web, Web3.js, WAGMI, you name them, VM, I think is the new hot thing. You can just use Unlock there. We also have integration with platforms like Magic, like Privy, like Stripe, Superfluid. I mentioned all of these. Again, feel free to ping us on Discord to get more. Typical protocol ecosystem thing. I'm not going to have time to show you the live coding, but I'll share the link in our Discord. Basically, it's a random blog that you can read content on, and really with less than 50 lines of code, you can create a token gate that basically requires users to connect their wallets, prove that they have an NFT. If they do, they can read the content. If they don't, they're prompted to purchase one of these so they can read this. Again, pretty basic. And the Unlock specific part here is, I'd say 5 lines. Everything else is like normal WAGMI and Web3, Ethers JavaScript that allows you to add the blockchain to your web app. There's a YouTube video as well, so if you're not tired of hearing me, you can actually watch me do that demo live. I've done it at multiple hackathons. Oops, sorry, don't play. We also have a quick way to do token gating on the back end. So your, Rails, Django, whatever Node.js application can do token gating on the back end. So no need for you to just do front end token gating. The mechanism is pretty much the same. Ask the user to connect the wallet, ask them to sign a message, verify the signature of the message on the back end, check whether the signer of the message has an NFT. If they do, great, you serve the content. If they don't, no, you don't serve the content. That's really, really basic. We also have a mechanism to create a bonding curve, the thing that I described earlier where the price of the NFTs go up every time somebody purchases one. You can also make cool stuff where price goes down if nobody has purchased in a while, etc., etc. We have multiple types of hooks that can be called and can be used to, again, change the behavior of the app. One really fun one is the on-token URI hook. It's a way to kind of change the metadata that the NFT is serving or the NFT contract is serving when somebody is querying it. So you can make these dynamic NFTs that basically look different based on the hour of the day, etc. I just got a stop sign, so I'm going to just move on quickly to the last slide. Actually, if you want to add unlock membership to your, so if you want to add monetization to your app this weekend, definitely use unlock. You should do that and think about how to make money. You'll also maybe win a prize, and you can scan that QR code to get to our YouTube page where there's a ton of me and a bunch of other people as well. If you are interested in hacking on top of Unlock, we also have a booth, so please stop by there. Another QR code, and they're all on the papers that we just distributed as well. And we're available on Discord. This time is not on the on the paper, so please scan that one if you just need to take one picture. All right. Thank you very much, everyone.
I don't know how to use the wire internet. Nah, never mind. It's fine. Let me see what's there. That work? Okay. Yeah. Okay. So let me start here. Ready? Can you hear me? Yeah. Hello, everyone. My name is Boris Polania. I work for near DevHub. We're basically near the developer DAO, and I will talk today about the boss. So let's talk a little about that. The blockchain operating system is basically a common layer for browsing and discovery web experiences, right? What this means is this is a decentralized front-end platform. It's like instead of deploying to Vercel or whatever, you just deploy here. It's 100% decentralized, so you cannot be censored, you cannot be taken down, and is based on React components. And that's basically what the boss actually does. So I will show a little the technology stack here. So the boss is like the base layer, and you can use any blockchain on the backend. It doesn't have to be near. You can connect to Ethereum or any EVM compatible that can be called through either JS. And then you can have like the data platform, the discovery platform. And your components that you develop, they sit on top. So what is a component? Basically, these are just small applications, and you develop and React like. And once you develop, you just deploy it to Boss, and the Boss do the composing. So you can basically put it available on the network. There are so many dev tools. You know, we have the IDEs, we have the open source, we have the documentation, and that's where I'm heading now. So let me see. Oh, let's talk a little about the hackathon. We have a $10,000 bounties, $10,000 in bounties. We have one first place of one, two second places of two, and three third places of one. The only thing you need to do is to deploy a component in Boss. The backend doesn't have to be near. Just the component has to be deployed on Boss. I will show a couple of samples later of components deployed on Boss with the backend on near, with the near smart contracts, or with components, you know, based on deploy on in other blockchains in Ethereum. Okay, so first I will give you a general architecture of how a Boss application works. So the main component is the website, and then you will have multiple components, right? In this specific image, the feed, the text box is it's called the components widget, the time ago widget, the comment, everything is a widget, right? So that's how you create your website on your front end on Boss. I will go a little more. So I will show you a little more, you know, the basic widgets. We have created some widgets, so you can easily use for everyone. So the basic widget, this one, is easy to see. Is, as you see, it's just declaring some variables, and this is running on Boss. What you're seeing here, this is running on Boss, right? So you just create some variables, and then you call it the same way you will call information or in React, right? So if we change the Anna for Boris, it will update automatically. So this is the kind of widgets you can develop. This is very basic. I will show later. There are many. Everything that is deployed in Boss is open source and can be forked. So these are just the basic we created when we developed the documentation. So we have an image uploader. We have one that manages Markdown, overlays. Like, let me show you how the overlays. So basically, this is standard overlays. So you will see more, but these are the basic ones. But I don't have much time, so I want to go to the basic. How do you actually deploy a component in Boss, right? So you will, let me see. In the documentation, you will see if you want to get this, you want to get the links, you will get the links to the online IDEs or the local IDEs. So we have online IDEs. Let me remove this one. So this is basically you can code your component on the left side, and then you can see the preview of what you're doing. It's very easy, very standard. So that's it. And when you're ready, you just go ahead and publish. You click here and publish. It will ask you it will show you the transaction. You will save data. Since I didn't change data, it won't ask for gas. But if I were to change, I'll show you later, it will ask for gas. As you know, Near is a layer 1. It's very, very low gas, very fast. So it would cost way less than a cent to deploy. It depends on the size, but many of the basic components you will do at the beginning will be very, low gas. But you can also use your local IDE, right? You can use Visual Studio, or you can, for example, use Cursor. So let me show you how it's. You just need to install the plugin. You just find it, and it's there either in Cursor or in VS, and you just create a new. Let's go. So ETHGlobal New York JSX. You put it there. Let's take some basic some basic code here. So we start somewhere. Put it here, And then let's ask the ChatGPT to, I don't know, add a drop down, drop down, drop down menu. We wait for it, and then you just wait for it. Sorry about that. So that you just copy paste it or whatever you want to do, or you can code it yourself, whatever. So you put it here, you save it, and you publish it. Oh, you can cancel. You can see the preview here in the same, you will see it here. And then you just go ahead and publish the component. Here it will ask, it's a new component, it will ask for gas. So you will have to have a Near wallet or my Near wallet. They are very easy to set up, standard wallets, nothing crazy there. Sorry, I'm assuming you know some basic crypto. So once it's approved, it will tell me here that it's ready, and then so I will just go ahead and find my ETHGlobal. This New York. Oh, come on, what's the name? ETHGlobal what? I cannot see it. I lost it. I don't know what's happened. Oh, it's in the other one. So it's called ETHGlobal New York City. Anyway, see. So that's here. New York City. So I have to find it. I cannot find it. Probably it's a little slow, the internet. But it should be published, and then you will be able to see it. So let's try to see what happens in case the internet's a little slow. Let's try it again. Okay. Yeah, so let's try. If it's not, well, never mind. So I don't know, it's a little slow, but then here you will find it and you will see it. This is the one I use for the workshop. It's a little slow. So it would show here, and you will be able to, you will see the source, and you will see it live here. So basically, that's how you deploy a component into Boss. So basically, you can do it on the online ID. You can do it on your ID BS-based IDE, and then you just polish it. That's basically what we are asking for the submission, right? You deploy a Boss component, and that's another part. So then you can. There's two ways you can do this. If you are here, so you can interact with near smart contracts here. For example, or you can interact with other non like Ethereum smart contract, right? So for that, you can basically use EtherGS, and then you set up your network. It has to be EVM compatible. So you basically set up the EtherGS, and you just call it the same way you will use their EtherGS in React. So this is the one that connects to Lido. As you see, it's a standard. Then you just call the EtherGS, you set the network, you get your approvers. It's the same thing. So you just use as EtherGS was working there. So you just don't need to add anything else. Just use EtherGS as to connect the smart contracts. Or you can see that this is a basic component. You will see it here. If you just call ethers, it's pre-installed. You don't need to import it or anything else. And then you can call, you can set up the network. If you don't want to use Ethereum, you want to use other EVM compatible, you just change the network and the ID and whatever you need, and you just can call smart contracts in another network. Or you can use near smart contracts. It would be better, simpler, faster. But you are not tied to use it on near smart contract. talking with near smart contract in Rust is beyond the scope of this one, but this presentation. But if you stop by, we can, and you're new to Rust, new to smart contracts in near, yeah, just come and we can help you with that. So yeah, so this, and then if you have on the backend, you don't want to do the backend in, I don't know, in any blockchain, it's still valid, right? You just need what we asking for the hackathon is to have the front end working on Boss, right? There is some if you go to the applications page, you will see many components. Every single component can be forked, so you can reuse the code. You can see the examples. For example, 1inch has a component running on Boss when you can do the swap. So this is a 1inch component. You can easily get the fork it and use the code as you need it, or you can go through all the the long list of components that we have. You see here there are many components here. You can just check what other people are doing and reuse them as you wish. So that's the basic idea. That's what we want for the hackathon. We are there. If you need some support in deploying Boss, just let us know. This is my. If you need gas money, if you need some near to start deploying, just ping me on Twitter, and we send you a code. You will give you more than enough. So because Boss is mostly mainnet, so you need you can't use a facet. You need some actual near. So ping me and we'll send you some nears, so you have enough to be able to code during the hackathon. And as I mentioned before, there are $10,000 in prizes. Yeah, stop by and beyond that, having your front end deployed in a decentralized platform is what this is all about, right? Like real decentralization, not having to rely on centralized entities. I think you should give it a look. This is working, and people. So far, you will see there are many components and a lot of projects and jumping into this because they have the benefits of not having to rely. And at the end, even in cost-wise, you will see it's more convenient than the centralized options. So, yeah, give it a try. We are on the booth. We can do any technical support you need, help you with the first component, help you with the near you need to deploy, whatever you need. Yeah, that's it. I leave this here in case you need it. And yeah, I hope to see you there. You can get some swag too. And yeah, see you there. Thank you.
pull up this thing. Okay. I am live. Presenter view. Okay. Perfect. Test one. Okay, it works. All right, nice. All right, cool. Is it? I have to. This is a presenter view, but it's not. How do I? Isn't this supposed to be hidden? Like, how does this work? It's supposed to be hidden, I thought, right? Like, but it's not hidden. Damn. Hold on, let me see. Oh man. How does this work? I guess I have to. I have no other option. I have to like pull it up. Like, hold on. Do you know how this works? Like, this is supposed to be hidden, right? I thought it was supposed to like only show. Hey, what's up, everyone? I'm sorry. I thought the presenter view would work. It doesn't, but it's okay. You know, I'm gonna keep it like this, and I'll just read from what I gotta do. But yeah, it's a pleasure. I'm glad everyone's here. So my name is Daniel. I'm from a company called Unlimit. So Unlimit is an OG payment company, right? So Unlimit started in 2009, and it started off in the payment space, right? And then they expanded off into different sectors like banking as a service. So in 2009, in the early 2010s, you know, when your e-com is blowing up, when all the online payment gateways are blowing up, Unlimit was actually powering a lot of them, and within like LATAM, within APAC, within Europe. So we have a huge online, we have a huge presence globally. So we do card acquiring, so we accept debit and credit card payments in a bunch of currencies. We have a bunch of payment methods, alternative payment methods, also, you know, your classic Apple Pay cards, banking rails. We do card issuing, and yeah, we also have a full stack BaaS solution. So this is just an example of what I was talking about. We have over 150 countries, many languages, bunch of payment methods, and Unlimit started this division of Unlimit Crypto within the past year and a half. So the idea was to take all of the rails that have been built over the past 15 years and apply them to the crypto game, the crypto world. So this is the question, right? Like, why does this matter on and off? Like, why is this important, right? So I had this as an example. I'm sure a lot of you guys know this guy. This is the Bitcoin pizza guy from 2010. The guy made the first payments, probably one of the first use cases of crypto, which was he bought a pizza with Bitcoin, right? So how has this evolved since then, right? Like when it comes to buying the dream to buy a cup of coffee with crypto, or to buy whatever you want with crypto. The first step, obviously, you have to on-ramp. So that's where we come in, right? So let me start off. When you go to a store and you use your debit or credit card to buy something, the question is, what happens? Like, why is Unlimit different? How are we different? What happens? You have to understand the exact flow, and I'll go through that real quick, right? So use the card holder. You're going to use a card given by your bank, and the bank is the issuer. And the issuers oftentimes are called principal members within networks such as Visa or MasterCard. I'll get to that in the next slide. So then after that, the card holder goes to the merchant, all right? the merchant accepts your card payment through a point-of-sale system, and the store has a bank relationship with an acquirer. This ensures that they can accept the card and the payments. So in this sense, Unlimit is an acquirer, so we are the acquirer in that flow. And then the point-of-sale system is going to connect to a processor, which is like your fizzes or your squares. And the processor's role remains as the mediator that ensures the conversation between the store, the network, and your bank go through. And then the processor informs the acquirer about the transaction details. The acquirer facilitates that transaction by connecting to the network and asks the card and the network, is there enough funds on here? And then Visa speaks to that, Visa or whatever card network speaks to the bank, and with those details, and the bank, which is the issuer, they check if there's enough money, and they send back a message saying either approve or decline, and then the processor transmits that message back, and if it's approved, the money moves and goes to the right place it has to go. So as you see here, just simple swiping your card and like buying something, there's a bunch of players. There's a bunch of routes that your order has to go through. So with that being said, the question is why do we need another on or off ramp? Why does this matter? So before my time at Unlimit, I've been working in the on or off ramp space for a few years now. I was at a company called Wire, and Wire is one of the biggest on or off ramp players in the game. Similar to Wire, you have a bunch of different people like MoonPay, Transact, a bunch of different people. The question is, how are we different? Pretty much what I described to you, because we own the entire stack. We are the processor, we are the acquirer, we do the settlements. So we own the entire stack of when you put your card in to when you buy crypto, we own that stack. Meaning, what does that mean? It means fees are not being taken off by, I'll be right back, I'm sorry. Okay, whoops. Okay, yeah, so that means essentially when you're a card holder and you want to buy something, it goes through that flow, you're not going through your stripes, your WorldPays. You're not essentially, your stripes and your WorldPays no longer are they taking bips and fees, exposing you to like FX spreads. Essentially, when you go through us, you have the entire stack in your pocket. So when you go on like an aggregator, like if you go on OnRamper right now, you'll see we're essentially like the default provider for a lot of pairs because of what I just explained. Because we own the entire stack, we essentially minimize the fees for the user's end. So as I was talking about, we are a principal member of different networks like the Visa and MasterCard. So the question is, what does that mean? So you have your JP Morgans, a lot of the banks, they're also principal members. That gives you the ability to issue and do merchant acquiring. So in order to actually do that, a lot of the competitors, they have to do it in a hacky way, right? You have to get a sponsor. You have to pay fees to essentially tap into the same network. We're already tapped in. So we're essentially avoiding fees on that end. And then obviously you have the processing, the acquiring, the settlement. There are fees being taken off at every route. But we essentially are able to bypass that because we own the entire stack. So the question is, so what, right? Okay, so what does that mean? That means now that you want to go and buy this coffee, up until now, because you had ridiculous fees, spreads, I mean, you're exposed to counterparty risk as well. So if any of these other on and off ramps, they do fraud, they have chargebacks, all of a sudden, now their partners, or now that on and off ramp, they have to pay $50,000, $60,000, $70,000 a month. They're exposed to higher fees because they've done chargebacks, right? The counterparty risk is there. That also gets passed on to you. For the sake of this hackathon, why does it matter? Because now you have the ability, with the lowest fees possible, no longer are you spending $100 to get $90 of crypto. That essentially, we're minimizing that as much as possible. So why does this matter? And this is where we come to the hackathon. So now that you understand essentially the premise of the technology is not, it's not new, like we're not building rockets. I think the important part is what I just described. It's just the why. Why does this even matter? But let's go into the actual hackathon. So we have account abstraction 101, right? So these are a bunch of different projects that are building in the account abstraction space right now, right? So actually we're working with ZeroDev, which is they provide the infrastructure for a lot of like account abstraction wallets and a lot of the functionalities. But there's a bunch of other players. I actually share this slide and all the different players after this within either like a Telegram group, which you can have my Telegram at the end, or within the actual ETHGlobal Discord group. So here's a couple of providers. I'll share that later. But so the question is, what is account abstraction, right? You've heard it a million times. What does it mean, right? It's very simple, right? So account abstraction is just having smart contract wallet functionality, right? The ability for smart contracts to send and verify transactions instead of EOAs like your MetaMask wallet, which can't do that. Smart contracts powered by account abstraction can be programmed with custom validation logic. So essentially, your wallet now becomes its own dApp. What does that even mean? So let me keep going. So with account abstraction, there are many functionalities that you can plug in. So you have here a couple. So you have gas sponsoring. You can pay for your users' gas fees in either any ERC20 token or ETH. But the ability to pay in really any token is a big thing here. Batching, bundling multiple transactions, providing the idea of session keys, right? So using a login method, you now have a temporary session key, which is essentially your private key. So that's a new concept. You have social recovery. So if you lose access to your account, you can essentially have a backup. So you have upgradable validation rules. You can upgrade smart contracts. As I said, the gas fees and different tokens, and with the ability to have different plugins, essentially you can pretty much create anything into these wallets. So the idea is, what is the idea behind this hackathon, right? So the idea behind this hackathon is, okay, you have unlimited on-ramps. Now combining that with the idea that you can build any logic within a wallet. What can you do? What does that mean? Imagine on-ramping into an account abstraction wallet. That wallet has logic written in it saying, hey, when ETH lands in this wallet, route that to an NFT marketplace, buy this NFT, and send it back to this wallet, right? So before this, users had to go in and do everything. They had to go in, Google an NFT market, figure out gas, figure out how to connect their wallet, figure out how to buy this NFT. With this, essentially where we're going now in the space, account abstraction, your wallet can be its own dApp. No longer do you really need to do anything and go anywhere. You can essentially execute logic to do whatever you want within this wallet. So here's some ideas that you could do. There's just some that I thought about, but you can do anything, right? So you have the ability to schedule transactions like recurring subscriptions. Automatically claim rewards for mining or staking, buying NFTs, as I talked about, working, if you're doing something related to potentially getting liquidated, you can create logic saying, hey, if I ever reach a certain threshold, fund my account, right? So this can all happen in the back. You're not actively doing anything, it's just pre-coded into the wallets, right? So what does this mean? It's up to you. It's up to you guys to figure out what it means, right? The ability to have your own dApp in your own wallet. Essentially, your wallet now becomes Curve. It becomes an NFT marketplace. It becomes anything you can really imagine it to be. So here is the actual resources to get this going, right? So I'll pull up this right here. And I'm going to share this. I'm going to share these resources within the Telegram group or the Discord. So let me go here. So we pulled it up. Let me refresh that. So this repo, essentially you can clone it and it brings this up. And I made this, obviously I'm going to share it with you guys so you can build on top of it if you like. So essentially you come in, we have all these different login methods. You can use one, come in here. You now have automatically a wallet address spun up for you. This wallet, you can essentially add any logic, anything you want within it that can execute in the Web3 world, whatever you can imagine it to be. But essentially, and I have these two examples as what you could do. So we've partnered with ZeroDev, as I talked about. We have them in our Telegram group if you ever need to like chat or have a question about how it works. But really, you can use any account abstraction platform you want. But we have ZeroDev already, so it makes it easy for you guys. But these are some functionalities. You can like pay for the gas, bundle transactions, and we have our on and off. We have our on ramp, which is essentially an SDK, which pulls up our on ramp in different modes, right? So you have overlay, embed. You can go to like hosted, pulls it up in a different thing, in a different window. We have our API endpoints. You can actually even get the widget through an endpoint, which returns back a URL. And we have our configuration endpoint. So this configuration endpoint shows essentially everything when it comes to the countries that are enabled, the payment methods, the networks each token is on or coin is on, the payment methods that are applicable to each jurisdiction. So essentially this will be the map of how everything, the possibilities of how things can link up. We also have the get quotes endpoint. You can get the quotes, get your orders that have already happened, and get a single order. So five endpoints, right? And then SDK. So the actual, it's nothing crazy happening here, right? I think the interesting part is going to be combining this with the actual, obviously, the AA wallets. And I will share this with you. I will share this with everyone. You can clone it, do whatever you want with it. I have some more examples. I'll share this as well. So we have this, for example. So this is going to be service son of, okay, let me pull up something. So you have essentially the SDK. You can essentially do whatever you want in here, customize it, add any param you want. You'll see a change within the actual SDK. We have that. And then we have the API docs as well, of course. We have the API docs. We even provide you ZeroDev's website. You can make an account there. It's self-serve. You can just spin up a test account and just pretty much plug it into the demo app and build whatever you want with it. So yeah, here are my Telegram and Discord names. You can, send me a message. I'm going to be out in the back. I have a table out in the back. If you want to come and ask me anything at all, go for it. We'll add you to the groups. We'll give you all the resources you need to get this going. And yeah, that's pretty much it right there. Yeah, let me know if you guys have any questions at all. I'm willing to take questions right now if you have any thoughts, ideas, concerns. Yeah, what's up, man?
So Unlimited is primarily like a fiat on-ramp.
So,
Choose your AA solution.
yeah, exactly. You can choose your AA solution. I just did ZeroDev because we've already built stuff with them. It's easy. We have the resources to help us. But if you want to go, if you know something else, yeah, I'm agnostic to whatever you want to choose. Yeah. And yeah, cool. I appreciate it, guys.
Hi, everybody. Can everyone hear me? Okay, cool. Hi, my name is Marcus Rain. I work for Edge and Node. I'm developer relations and success, and I'm working on building the graph. So thank you so much for arriving at this presentation where we are going to be going through querying Web3 data with the graph. Right away, let's go ahead and go to the important part. If you are hacking and you are planning to build with the graph, this is the QR code that you should scan. This provides you with hacker technical support where you could reach out to us on our Telegram. There's also going to be quick start videos, documentation, lots of links to get you started. Also, the slides of this presentation and the repo associated with this presentation will be in this QR code. So once I see all phones down, I'll be going on. Okay, oh, phone up. Also, every month I write a Graph Builders newsletter for builders like you for any updates that are in the ecosystem. There we go, another phone up. Okay, phone up. Okay, phones are down. All right, so if you are hacking and planning to build with the graph, these are the bounties available. And if you want to pay attention to the second category, the best use of existing subgraph or substream, that's if you simply have a query sent to the graph ecosystem and actually use that in your dApp. And that's what we're focusing on in this presentation. Just sending a query, we're not actually going to be building a subgraph. So let's get into it. The graph network. What is the graph network? The graph network is decentralized indexing and querying. There's 250 plus indexers worldwide that are organizing and providing your data, and there's 7 chains on the graph network with over 1,000 subgraphs, which means over 1,000 endpoints for you to all query. It's pretty cool. We could all use this and build already today. And really quickly, what is a subgraph? Well, a subgraph, if you look at this, is pretty much this. You get disorganized data, and that's on the blockchain. And then from there, a subgraph will organize that data. And then from there, you have nice buckets at the bottom that we can query and actually provide data to our dApps. It has an API endpoint that we're able to use. It has when you build a subgraph, you actually build it in Subgraph Studio. And then when you have that subgraph built and we have it going on, it starts centralized. And when we iterate and build it and build it and build it, we then publish it to the graph network, and then it becomes decentralized. So that's just important to know. Every subgraph that you find in this Graph Explorer that we'll go through in a second will be decentralized on all of those indexers around the world who are indexing that subgraph. So, and why might we go on the graph network and actually publish our subgraph? The subgraph will have increased uptime, speed, and redundancy. And these network subgraphs exist in a marketplace. When we publish our subgraphs to the marketplace, we have our subgraphs being competitive. It's actually tokenomic incentivization going on in there with the GRT utility token. So the indexers are incentivized to work harder for you. All right, that's really important as a builder to know that when you see a subgraph in the Explorer, that is one that's a competitive marketplace subgraph. Okay, let's keep on going. Let's take a look really quickly at the Graph Explorer. Here we can see, this is the marketplace. This is a little GIF of it, and you can go through, we can all go through and check it out and see right there, there is the endpoint, and that's the query URL. We'll go through this in a little bit with some actually exploring the Graph Explorer. Let's shift a little bit after that high-level overview into something that is more what we are trying to do today, which is querying, all right? We actually want to get some answers. So it's not the answer that enlightens, but the question, and that is really important. We want to ask some good questions. We want to get some good questions from our Web3 world, and let's go into that process right now. Okay, the steps to query a subgraph. First, we have to set up an API key. We have to set up that API key to access the graph network and actually send out queries. The next thing, we need to find and assess a subgraph on the Graph Explorer, which is exploring the graph network. Number 3, we then design queries in the subgraphs playground that we are interested in. And then number 4, we integrate the query that we like with our dApp, and we can just send it out and get to work building. Okay? So first things first, let's go ahead and set up an API key. We'll go to thegraph.com. And we'll go up to Products and Subgraph Studio. And we'll go to the top, and we'll go to Keys. And really quickly, I want to preview, we are excited and always, it's really exciting to see that we're going to be putting in subscriptions for queries, so you'll have a set rate per month if that's something that interests you. That's not what we're doing today, but that's a little preview. I'll talk about that a little bit later. But these are our API keys. When we set up an API key for the first time, we actually get 1,000 free queries. So if any of us are setting up API keys today, you'll get 1,000 free queries. And this is mine that I've built for myself. And this is also a query key that was created for everyone here. So if anyone here runs out of their 1,000 free queries, go ahead and reach out to us on Telegram or find us at the booth, and we'll get you this query key right here, and you'll be able to keep on building. Okay, that's really important. We don't want you guys to stop building. The query key is right there. So just to create a API key, just go right here, live demo key, and from there, that is it. We have our query key, and we're able, the API key, and from there we're actually able to fill that up with the billing balance and then continue on with building, okay? So now that we have our API key, we have 1,000 free queries and also a free API key that's able to be used. Let's move on to the next step. Okay, number 2, we want to find and assess a subgraph on the Graph Explorer. All right, so let's dive in to really what that might look like. How do we find the subgraph? How do we assess it? What does that actually mean? Well, we can go through a few steps here. And the easiest way to assess if a subgraph is of high quality, because remember it's in a marketplace, is if it is a Masari standard subgraph. If we all see a Masari standard subgraph, that subgraph has been built by the Masari team, and that has a standardized schema and a actual standardized way that we can interact with it, and that's quite powerful. Let's go through really quickly their website that shows a really nice list of Masari subgraphs, and also we can see that in the Graph Explorer, but this is through Masari. Each of these are bridge subgraphs that we can access blockchain data. And they all are standardized together. The derivatives subgraphs, these have their own standard. The derivatives here have their own standard. The exchanges, these have their own standard. And soon, later in the presentation, I'll show you why this is so powerful. Just know that subgraphs.xyz is a helpful place to see all the Masari subgraphs in one location. And then from there, you can be able to use that power. And I'll show you how that is empowered very soon. Let's go back. And let's say we see a subgraph on the Graph Explorer, and it's not a Masari standard subgraph. Well, we got to get a little bit more, we have to know the actual protocol a little bit better. We have to understand what's going on. And there's 3 things that we could look at to understand if a subgraph is of higher quality, or moderate quality, or lower quality. Because all these subgraphs are permissionless. Anyone could publish these. We need to assess if it's helpful in the marketplace. So let's go through and find and assess a subgraph in the Graph Explorer together right now. Let's go to thegraph.com Explorer. Okay, so here is the Graph Explorer. And right at the beginning, we see there's 932 subgraphs, 932 endpoints, 932 locations where we can access data through the blockchain. And we have even more on Arbitrum 1. And really quick differentiation, these are subgraphs indexed by indexers who are incentivized by the GRT utility token on Ethereum. The Graph protocol is on its process of migrating over to Arbitrum 1 to take advantage of L2, all the advantages of L2. And so right now we see 376 subgraphs that have migrated from Ethereum and are currently being indexed on Arbitrum 1. And just so you know, if you are going through this, this is going to help you identify these different batches of subgraphs. So let's go ahead and go to Ethereum, and we will see let's go to a CryptoPunk subgraph. And I want to be very specific here. I want to look at one community of NFTs, and from there we can start to dive into a little bit more detail. So right away, we see this is organized in a way where curation signal is quite important. And that's important to understand, where the ones with the highest curation signal have the most GRT incentive, tokenomic incentives going on to reward those that participate with this subgraph. And that goes into a little bit of the tokenomics. I'm not going to go too deep into that because y'all are builders. We're all builders. It's more important just to know the ones with the most signal, also known as curation, typically are the most valuable subgraphs and have the most proven quality in this ecosystem. So right now, this is the one that we're saying, and that's the curation. That's the signal. That's the one that we want to take a look at. So let's dive in there, and let's move on. So how do we assess this subgraph's quality? Let's keep on going. This subgraph is actually finished indexing. That's awesome, because indexing takes time. This is already complete, so we're getting fresh data at the chain head, which is great. Let's keep on going, all right? Let's say, all right, the next thing that we want to look at, first we want to look at the curation. Then we want to look at the documentation. And any good subgraph is going to have its actual code available to the public. And we can see right here, this developer, Jerry Okolo, has provided his documentation right there. So let's take a look at what he has done. Let's see if there is quality documentation. And we can see, awesome, there is quality documentation. We know what's going on with the subgraph. Because this is permissionless, it's important that we can investigate, all right, what's going on with this? Is this gathering the data? How is this organizing the data? That's really what we like. Okay, and the last thing on that previous slide was comments. So it's curation, it's documentation, and the comments. Specifically, the comments in schema.graphql. Now, why are comments important in this location? That'll come up in a little bit when you're playing around the playground, but just I want you to see here that Jerry has been kind and put in comments here. And why might that be powerful? Well, we'll see when we're in the playground why that might be powerful in a little bit. But if you are diving into a subgraph and we're able to see comments in this location, that helps us as builders really get building really quickly because this developer has taken the time and kindness to really make our querying experience much more effective. Okay? So curation, the documentation, the comments in schema.graphql of the subgraph. Okay? Now, I think personally this subgraph is pretty good. It's a pretty dang good subgraph. We're able to say, all right, we've got some good curation on there, we've got some documentation, and also has comments. The next step, let's go back to here, would be to begin to design some GraphQL queries. We've found the endpoint we want, we've found the actual subgraph that we think has the information that we want because it's gathering it and organizing it in a very nice way. The GraphQL queries are important because we have to start designing these little queries to say what data are we getting and is it the actual data we need for our DApp. So the few features that the playground has, there's many, but we'll just go over the filtering, some logical operators. We could save some queries, and there's many, many more features that are available in the graph.com docs, and you can see how it has those features in there. So let's think of some queries and just demonstrate how we might go through some investigation of this subgraph. So here's some example queries, and we'll start simple. First 10 transfers in CryptoPunk's history. Let's go ahead and dive into that one, the first 10 of all time. So we'll be here, and we'll go to the playground. It automatically populates with the query, and it has accounts, and it has punks, but we don't want the account entity. We don't want the punks entities. Remember, we want to look at the transfers, and that's really how the schema is organized with every subgraph. It creates these buckets, also known as these entities, in the schema.graphql. And these are the entities that we can begin to query. And we're looking for the transfer entity right here. And we have a single transfer if we want to see that, but we could also look at many transfers. And we want to actually take a look at many of them. So we'll click on that, and that little arrow that brings it down is allowing us to say, all right, let's look at transfers, and we'll look at the first, okay, 10, very nice. We could look at 15 or 20 or 100, whatever we want. And then we also want to look at the first 10. So we'll say, all right, we got to look at the timestamp. That's going to be important because it's timestamp. And then we also want the ID. And then just to understand the ID a little bit, we could hover our mouse over different locations in the timestamp, and we'll see that in just a little bit why that might be powerful. Coming up, why that might be powerful when we're looking at more complex information. That hovering is quite powerful. So let's go ahead and say, all right, we want to order this by the timestamp here. And we want the order direction. Okay, very nice. We've created a little query, and bam, we've got this back, and now it's ascending from the beginning timestamp, and it's going up and up and up, and we have the IDs right there. So already, we have a valuable query that we can then bring into our actual DApp. And then from there, we can keep on playing around. We can play around and play around, find different bits of information that we like, and go from there. What's the next question that we might want to answer? Okay. What's the total value of all sales, the total supply, and the number of sales on the CryptoPunks contracts? All right, so that's a little bit more detailed. Can we actually get that information? Has Jerry done the work at actually doing some compute on the subgraph and then providing us that data? Let's go see. We'll go here, and we want to look at, we don't want transfers, we want contracts. And we'll get whatever's there, and here we can see the total amount traded. And if we hover our mouse over the actual location, we can see the comment pop right up here. This is where the comment comes through, so if the developer has done a nice job putting a comment in there, we're able to see exactly what this means when we query this property, because sometimes properties can be a little bit vague. And just by putting that in there, we know exactly what that means. This number right here, what is total sales? We just are able to hover our mouse over. Thank you, Jerry, for putting those comments in. That is awesome, because we're able to understand this better and get building. Let's keep on going. going with this journey here. This is a comparison of two Masari standard subgraphs. Remember those Masari standard subgraphs I was talking to you about? These are both under the same category, they're both standard subgraphs that we can query, and we could send the exact same query to any Masari standardized subgraphs that are under the same category. And that's really powerful because let's say we have 5 or 6 different subgraphs, each going into their own different protocols. And then from there, we just want to send one query to all of them. All right, using Graph Client, which I'll talk about in a little bit, we can do that. So I'll just demonstrate this query here. Find the TVL for August 20th, 2023. We can look at the Curve Finance Ethereum subgraph and then send that out. We get that information right back. And then also, we're able to send the exact same query, because this is a standard subgraph, it's a Masari standard subgraph, here. And we get that exact same information back, because the schema is standardized. It's going to help you get information from many different protocols all at once, all to one location through Graph Client. That's a really powerful thing. All right, so, and that's through subgraphs.xyz. Remember, go through there and see the different categories for the standardization. If you want some homework, here's some homework, and that's going to be fun for you. If there was to be one QR code for everyone to scan to integrate queries into their dApp right away, it would be this one. This is the repo that I created for everyone here that gives demos of a vanilla JavaScript and Python query, an Apollo query, a Graph Client query. Graph Client was created by the team that's building, many teams that are building the graph. That allows for one query to be sent out to multiple subgraphs all at once, which is really cool. There's auto-pagination in there, so we can have lots of responses. Really cool. And then finally, at the bottom here, there's 2 things I want to pay attention to. Once I see phones down, I'll move on. Phones up, good. Yep, I see it. Thank you. 2 minutes. Woo! It's quick. All right, phones are down. Who here likes machine learning? I think it's super cool. If you are interested in diving into machine learning, this is an amazing library that connects directly to subgraphs and is written in Python, so we can go ahead and start going into machine learning data science right away without having to go and do anything else. Just use this library, and it connects right to a subgraph, and you send queries right from there. Super cool. And then also, if anyone here likes dashboards that are no code, this is dapplooker. It's awesome. It's built on top of subgraphs and substreams, and from there, you could literally drag and drop these into your dApp and have these analytics right there, and you don't really have to do any front-end design. It just literally drag and drop, and that's it. It's really, really nice. It's really good. So yeah, Playgrounds and dapplooker. One final thing, billing subscription. That's a new thing. If anyone here is querying the subgraph a lot and wants standard monthly rates, this is a subscription. So it's a flat rate. You don't have to worry about big spikes and big drops. This is something that's rolling out. We're in beta right now. If you have any questions about this, reach out to us on Telegram or meet us at the booth. We can get you signed up, and you can actually use that. So some takeaways. We love decentralized indexing. There's 1,000 subgraphs and the endpoints ready for everyone here to query. And then go ahead and play in the playground. Thank you very much. And if anyone wants to scan this and tweet, that's the lifeblood of crypto, so it does help. All right.
Hey folks, I'll just let everyone quickly settle down. I hope you're enjoying your first day of ETHGlobal Hacker House. Just want to get, so we're really short on time. This is a 20-minute presentation. I want to make sure this is short and sweet and useful for everyone who's here. So by show of hands, I'd just love to know who here has written a Cairo program. Okay, so not very many people, but I'm extremely happy to see those who have. And how many people here have made a transaction or used StarkNet Layer 2 in the past? Okay, so still the minority in the room. Finally, how many of you know what an Ethereum scaling or Layer 2 solution is? Okay, great. So we can skip past all of that. Just sort of begin by telling you a little bit about myself. I am the developer relations engineer for StarkNet Foundation in the US. I'm not very far apart from some of you in age. I just graduated college last year with 4 years of research in DeFi and game theory. And if you want to connect with me or get to know anything about me, feel free to hit that link tree up. And bonus points for anyone who understands the joke and the name over there. So I have a few talking points today. We like to say on StarkNet, you come for the ZK and you stay for the AA. So the guiding point for today's talk will be AA, account abstraction, but we'll be going over generally what we're up to at StarkNet. So feel free to let me know when these slides are sort of redundant or you already know what I'm talking about, so we can just sort of brush past them. Blockchain accounts. People familiar with the concept? Generally, the blockchain account is basically composed of three things: address, keys, and business logic or some software that's deployed on-chain, and then some metadata. Now, the whole idea of account abstraction, for those of you who haven't heard this phrase before, is unlike Ethereum, where these three things come bundled in a package, you're able to separate your addresses and keys from the business logic and data and actually write your own accounts as smart contracts and associate them with a certain address or a certain set of keys. And that allows you to create heavily customized accounts. So I hope everyone's familiar with the idea so far. Sort of a quick slide I borrowed from the Ethereum Foundation's website that shows how your address maps to the data that I was talking about. Sometimes it's also called metadata or state data. A lot of the code that you guys are going to be deploying as smart contracts are going to be mapped to your account address through the code hash. And let's talk about StarkNet, since this was really the minority in the room. People weren't so familiar with StarkNet. StarkNet is a layer 2 solution that uses Stark proofs, which are a form of validity proofs, to accelerate Ethereum. We do so by essentially executing, or by validating and executing programmatic logic on a layer 2 blockchain. It's just a blockchain. And then processing those transactions, bundling them into a hash, and reporting them to Ethereum Layer 1 for them to be included in Ethereum's blocks. And we provide Ethereum with a mathematical proof that all of these transactions were validated correctly. So has anyone here ever heard about the blockchain trilemma? Right? So it's scaling, decentralization, and security. Essentially, Ethereum as a layer 1 blockchain, a final settlement layer, focuses on decentralization and security, and we pick it up when it comes to scaling and borrow Ethereum security guarantees in a mathematical sense in order to do so. There are several constructions of validity proofs out there. There are different roll-ups that are operating on Starks, Snarks, Blonks, etc., though there seems to be now a narrative in favor of Starks. Basically, Starks are a form of validity proofs which use lean cryptographic primitives, allowing the proof generation cycle to be extremely fast and for it to be theoretically post-quantum secure. However, this does imply that the proof is a little bit bigger and clunkier and takes a longer time to verify, but at StarkNet, we've optimized the proving process to a point where that's a significantly reduced concern for us. So just as a visualization, you can think of all of these validators as Ethereum validators running the full Ethereum client. It's darknet processing a bunch of transactions, creating a proof that the validation was done correctly, and allowing all of these validators to be sure that this is actually done correctly without having to commit large computational or storage resources to that. So far, I hope you're all on the same page. I'll quickly go over Cairo. I think only 2 or 3 people here have worked with Cairo in the past. So Cairo stands for CPU of Arithmetic Intermediate Representation. If you're not familiar with that, you don't necessarily need to be. ZK and proof systems can sound a bit sort of technically intimidating. I'm not a PhD myself, but I've learned that you don't really need to know those mathematical details to build some really cool programs. Has anyone here ever written a ZK proof or tried to do that in the past? So if you use any of sort of the more playground-like libraries like Circom or Zocrates or Remix, you'll notice that you have to express your programmatic logic as a circuit in order to write a proof. And that's quite a shift from the traditional paradigm of just writing a computer program that works on a von Neumann CPU architecture and uses a RAM memory model. So at StarkNet, what we do is essentially we've created an intermediate layer, a VM, that allows you to write expressive smart contracts and software in general in a Rust-like programming language. And then we constrain and arithmetize and basically turn your computer program into a provable program and generate the proof automatically by construction of the system, so you don't have to think about building a circuit from scratch. So it's sort of an old, computer programming experience translated quite seamlessly into ZK scaling land. Very importantly, we have a Stark verifier that's implemented as a smart contract on Ethereum, so all of your Cairo code can be verified on Ethereum. So just want to quickly help you guys visualize the naive way of verifying each transaction using, if you didn't have a proof system, would be that you had to rerun each transaction on each node in order to verify what's going on in the layer 2. That would be order of n, whereas with proof systems, it's polylogarithmic. And as you can see, as the number of transactions in a block increases, the difference in time and resources is, well, stark, to say the least. Well, no one got that joke. So yeah, finally, let's get down to account abstraction. I do want to be clear, account abstraction is not necessarily something that only StarkNet is working on. It's already quite a big there's a big push to bring account abstraction to Ethereum. We've already spoken about what it implies. It implies separating the addresses and the signing keys from the programmatic logic of an account and allowing people to express their own accounts. On Ethereum, as many of you know, the block that you get of 3 things is called an externally owned account. It's different from a smart contract, and it's supported at the EVM execution level. Now, there are some great things about having EOAs. They've been around for a long time, so developer tooling around EOAs and integrations are very mature. You have products that have hit billions of dollars of market capital already, like hardware wallets and browser extensions that are quite good to use. I use them myself. But there are some limitations as well. First of all, an EOA is not a smart contract, which means that you can't express programmatic logic on it. So for instance, if you want to use something like a multi-party signing scheme, you have to go through a third party like Gnosis Safe, et cetera, whereas you could, if an EOA was just another contract, express that functionality in your own code. Some arguments also indicate that EOAs create a bad user experience because this is just sort of a tale, and I'm not paid by Bravos, but I'll be taking you through in just a couple of minutes the Bravos I see. There's a story of Bravos, which is a commonly used smart contract wallet on StarkNet. Basically, Bravos, because it uses abstract accounts, was able to create a 3-factor authentication for their wallet user experience. So you can sign your transactions by simply clicking the button, which is the familiar UX. You can also sign transactions with Face ID. And you can perform social recovery very efficiently on keys. And there was a crypto influencer in our ecosystem who accidentally revealed their private keys on a Twitch live stream some time back. And their Ethereum keys, which were exposed, unfortunately led to their fans taking away most of their funds from their accounts. But since the Bravos account was settled on 2FA and they needed to sign with the facial identification, the only wallet that people were not able to exploit, despite knowing the private key, was the Bravos wallet. And then finally, one of the benefits of account abstraction, which is extremely cool to me, and I will run through this slide. Too many slides to run through, but account abstraction allows you to essentially convert your phone, doesn't matter if you have an Apple or an iPhone or a Google phone, into a hardware wallet by simply implementing the secure execution environment's signature scheme in Cairo. So yeah, that's sort of the TLDR that I could do in 10 minutes about account abstraction. There's some other benefits, such as creating gasless or seamless user experiences for people using a dApps, because you can create something like a paymaster that pays gas fees as meta transactions. AA on StarkNet supports multi-call functionality, and so on and so forth. The salient differences between AA on StarkNet and Ethereum is that on StarkNet, AA is supported at the protocol level because it was a concern that we addressed from day one. We have sophisticated developer tooling around AA, and I'll be sharing that with you in just a second so you can use that in your projects over the hackathon. And we essentially are able to also provide fee delegation for dApps just the way Ethereum does. So yeah, this is what I was talking about. You're able to use the secure enclave. That's what the secure execution environment on an Apple phone is called, and basically turn that into a hardware wallet purely because of the power of account abstraction. So I understand that I'm short on time, so there's a great talk about account abstraction that you can listen to if time allows at this QR code. I highly recommend it. And yeah, now, how many of you have a Bravos wallet on your Chrome browsers? Okay. So I'll get to this in just a second. First of all, I want to give some direction to the builders over here who might be interested in building something using StarkNet over the next couple of days. First of all, if you're interested, resources are quite concisely bundled in the StarkNet book, which can also lead you to our docs. Everyone here is an experienced hacker. You're all meat eaters, so I'm not going to hammer this down too much. If you want some extra help, though, Medium blogs are a good place to look at. There are 2 directions that I'd like to encourage people to consider over the next 2 days. The first is zero-knowledge or verifiable machine learning dApps, which can be implemented quite easily using the Giza ZK AI tooling. You're basically able to create machine learning models in familiar frameworks like Jupyter Notebooks and Python, and then transpile those into Cairo bytecode and verify them on StarkNet very efficiently. Actually, if you follow that QR code, you can take a look at how you can implement a neural network that can recognize, differentiate between different texts in less than 10 minutes. And then if you're interested in on-chain gaming, the hottest narrative, or one of the hottest narratives in the StarkNet ecosystem right now is the Dojo Gaming SDK, and some really cool games have been coming up using Dojo SDK over the past couple of months. Actually, if you think you can pull it off, I would even consider combining these ideas and creating games which use an artificial intelligence agent in a gaming experience like a chess game or something like that. It's possible. Those QR codes will lead you to some sample projects that you can consider. So yeah, As I understand, we have 4 minutes left, and so I will not get into the coding right now. But if you quickly scan this QR code, it will lead you to, well, I'm already at Chrome. It will lead you to an article. I would just recommend following this article. It will take you no more than 10 or 15 minutes, and it will help you set up your local developer environment for Cairo. Setting up local development environment for Cairo is as simple as typing 2 lines in your command line interface. All you need to do is set up a command line tool called stark.li and a package manager called scarb, and that is it. And then you can follow this to essentially create, so I created a wallet for the express purpose of this demo. This is Bravos. It's a pretty useful mobile wallet as well, but you can create a wallet with some testnet ETH in there. I recommend using Starknet Gurley 2. These are our 2 test networks. Just set this account up. You're able to seamlessly integrate it with your CLI. You're able to define your own account as you want. If you want to use RPC calls, highly recommend using Alchemy. It's extremely easy to just create a new app and set up. You don't need to, I mean, it doesn't matter if you do either one of those, but you can create your RPC node over here. This is where you can download Bravos. And then finally, I want to make you familiar with a block explorer that I highly recommend called StarkScan. Basically, yeah, I'm sure all of you know how block explorers work, but you can get some pretty decent insights just by playing around with this. So yeah, the instructions are quite clear over here. My team and I will be walking around. You can locate us by virtue of either Starkware shirts or ID cards, and just, yeah, stop us, ask us questions. More than happy to help you in your projects. As I said, highly recommend taking a look at the Giza ZK AI framework and Dojo Gaming SDK. So yeah, I have 1 minute left. If anyone wants to quickly ask a question, then we can call it an afternoon. Yeah. So Warp is deprecated. It was so before we had Cairo as we have it today. We had an older version which was a little bit more like Python, not quite, but a bit like it, and it was a little bit harder to use. And so we created a transpiler from Solidity to Cairo, but now you're able to write Cairo programs in a pretty much a Rust identical framework. So Warp is no longer required. Yeah. Anything else? Awesome. Okay, I believe we are right on time then. I'll stop sharing, but thank you so much for hearing me out.
All right. Thank you all for coming to my talk. My name is Rahat. I'm going to give you an intro to modules using the Biconomy SDK. So really quickly, my name is Rahat, head of DevRel at Biconomy. Formerly been a front-end engineer, founder, hip-hop artist. I've retired. I no longer do freestyles, I'm sorry. But you can follow me on a couple different places, Twitter on Rahat Codes, rahat.lens on Lens. If you need a primer on account abstraction, I did do an intro to account abstraction at ETH Paris. You can see a replay of that on this link. So if you're new to account abstraction in general, you can check that out. This is not an introduction course to account abstraction. This is going a little bit deeper into a newer feature that we just recently released. So I will give you just like a small kind of like, overview, but if you want to go deeper into what account abstraction is, highly recommend checking out this video and some of the resources. Yep. This is, okay. It's not showing my slides.
Go to your system preferences, displays, mirror.
Cool. All right, cool. So this is the QR code. If you want to go through that introduction to account abstraction, highly recommend going through this. It'll give you an overview, what account abstraction is, and just like a general introduction to our SDK. So really quickly though, I will go over some of the details in that video. So the Biconomy SDK allows you to tap into the full stack of account abstraction. So we give you paymasters, bundlers, as well as packages to create your own smart accounts. So the smart account package helps you to deploy your own smart accounts, as well as create user operations that eventually get executed as transactions. Our paymaster package, you use one URL, and you can switch between doing gasless transactions as well as doing ERC20 token payments for gas. So we're really focused on like the developer experience. You just use one URL, switch the mode, and you're good to go. Bundler package, you can use our bundlers. We have bundlers available on several different chains to actually send your user operations to the entry point contracts on every chain that we're deployed on. So now we're introducing the Smart Account Platform, which is our focus for this hackathon, as well as like some of the different prizes that we have available for you. So the Smart Account Platform is built around extending our smart accounts to allow you to create and use different modules. So some of the modules that we have available for you today that you can start using allows you to do a few things. We have a regular ECDSA module, which just relies on an EOA to sign and verify your messages. Similar to like the experience that we've had with our previous offering, with our previous version. But going a step further, we now also have a multi-chain validation module, which acts the same way as the ECDSA module. You use an EOA to sign for your transactions, but using that EOA and one signature, you can interact on multiple chains, all with one signer. So you don't have to have your user switch between different networks. You can just interact seamlessly across chains and completely abstract away the need for your user to even think about what network they're even using. We have session key managers, which is going to be the focus for today's workshop. This enables the use of sessions and session validation modules for your dApps. So think of it this way. You sign once, and then you start doing transactions, and you don't have to keep signing over and over again. You unlock actual fluid Web2 experiences where you can do things like working on Web3 social. Sign once, you don't ever have to, like if you think about if you've ever used Lens protocol, you don't have to sign every single time that you like something or comment or post. It's a similar experience to this. So like I said, today's focus is on session key modules. let's dive into a quick demo and some code. So here's the demo first. Hit this connect to Web3 button. MetaMask will pop up. I'm going to connect. Cool. I've connected, and although my address ends in BDFD, you'll see that the smart account address is different. This smart account was deployed using my EOA as the signer. So this is showcasing the ECDSA wallet here, the ECDSA module. I'm going to hit this create session button. In the background, a session will be created. I just sign once. So this is what I meant before. I sign once, right? Every single other transaction that I do in this demo, I will not have to sign again. So it's creating a session for me in the background, letting that kind of go. Cool. Success session was created. Now, in this demo, I'm simply just going to hit this transfer 1 USDC button. What's going to happen is I've already preloaded my smart account with some Testmatic as well as some test USDC. And I'm going to send USDC back to this account. So just to show you right now, there is 29 USDC on this smart account. I hit transfer 1 USDC. In the background, it's happening. No MetaMask pop-up, right? Nothing that I have to sign. It's just a nice little seamless experience. I'm just waiting for it to kind of like go through in the background. Cool. I get my actual transaction happening here. But before we look at the transaction, you'll see that my USDC balance went up to 30. Didn't have to sign, didn't have to do anything. This is an actual, like, think about this as like an actual experience of like how a Web2 user would use Venmo, right? You're sending some funds to another user, but you're not signing every single time. You're not approving it every single time. Now you can actually unlock these experiences on chain. So this is the transaction that just went through about 12 seconds ago, sending 1 USDC from this account to the other one, all on the Polygon Mumbai chain. We're on major, pretty much all major, almost all major EVM chains. If you want to look at our bounties as well as some of the chains that are available here, we're available on Polygon, we're available on Base, we're available on Linea, as well as Arbitrum. So if you're hacking on any of those chains for the hackathon, you're able to use our SDK. Cool. So that's a very basic example, right? Just kind of like what's possible. Let's see how that actually works. I'm going to go over to our documentation and show you an implementation of the session key a validation module smart contract that actually allows this to happen. So you can actually use this as an example to build your own session key validation modules. But in this instance, this is an ERC20 session validation module, which takes a few different permissions for you to look at for the little demo that I just did. One, it's going to take some information for the session key itself. This session key is going to have 4 different arguments in it, and I'll kind of go over those later. It's going to take a token. In this case, I sent USDC, so the USDC token address. It's going to take a recipient. In my case, I hard-coded the recipient only to be my other EOA. You can obviously change this logic, but this makes it so that within the session, I can only transfer ERC20 tokens to that specific account. So here we're like looking at the different permissions of what's actually allowed in the session. And then there's just a max amount that I cannot cross over during any of these sessions, right? So this is just doing all of the checks, making sure that the token that is supplied in the argument matches the token in the session key, which would be the USDC that I used. This is also requiring that the call value equals 0. If you want to, do your own kind of like session key validation module, let's say you're minting an NFT that needs some value, you would remove like a line like this and just make sure there's a certain value attached to it. So this is just like a base for what you can use to actually build your own modules. Next, it's just checking if the recipient is actually the same as the one that's specified in the session. Again, I can only send to that one recipient, and making sure that the max amount is not exceeded. This specific function here and this specific function here, they do more or less the same thing. This function is called from our session validation manager. The manager, essentially, you supply it a deployed smart contract. In this case, we deploy this contract for you, so you can start doing the transfers yourself. But if you wanted to use your own contract, build it on top of this, deploy it, just switch the contract address, you have a session validation module that you can use with our SDK. So this is called specifically by the session key manager. And if you're doing something like batching sessions together, we have another batch session router, which allows you to batch multiple different types of sessions. This is the function that's called in that case. If you want to learn how to build, if you want the base, kind of like how to build, we have the actual contracts that are linked here, so you can use the interface and follow the example here to build your own modules, deploy it, and use it on our SDK. How do you actually use it? So to actually use it in a application, first thing you want to do is set up your Biconomy Smart account. In this case, I'm using the Biconomy Smart Account v2. That's our latest version of the Smart account itself. You create an instance of your bundler. You can grab your bundler straight from the dashboard. For testnets, you can actually just use variations of this link and just change the chain ID. Also, from your Biconomy dashboard, you can grab a URL for your paymaster, and I recommend using your own URL because none of your transactions will work on this URL. But cool, this is just like a connect button, just to connect to the actual MetaMask wallet. Nothing fancy here. I'm just doing an Ethers request for request accounts. And then I'm using our ECDSA ownership validation module to create the signer that's going to control the smart account. So that's this step here, essentially passing the signer that I get from MetaMask over to the ownership module here. The cool thing about this is we're signer agnostic. This is one way of me creating a signer, a simple way through Ethers.js. However, you can use any type of authentication system that you want. Another sponsor here is Privy. If you wanted to use Privy to create a signer, you can actually use their SDK, create a signer, pass it to us. Now you have a Biconomy Smart account created by the signer from a Privy account. And this is the same if you want to do something like Wallet Connect. You want to use Wallet Connect to connect, get your signer, you can do that too. This is just the basic example. This is not the only way to create the signer. You can create the signer in any way you want. As long as you pass the signer to the address, you're good to go. Last thing here, we create the account. These are just the different validation modules and everything you need. On the ERC20, on the creating the session side of things, where you actually create your session, one thing that I mentioned before is you're essentially using a deployed smart contract, right? That's the smart contract that we went through before. Replace this with any smart contract that you want that you've built on top of that for your specific use case, right? So if you want to add more permissions, more granular activity onto your module, you can do so. You want to replace it with like an ERC721 module, go ahead. Whatever you want, all you got to do is just replace this address. Cool. In terms of the actual transfer itself, again, we're making sure that we're using that ERC20 module. We're making sure that we use the session key manager module. This is all just copy and pastable things from our documentation. This repo is available on GitHub. There is a step-by-step how to recreate this exact project on our documentation as well. Just for the interest of time, I can't go through every single detail. But here, I'm transferring the funds to a specific EOA, which is the EOA that I created before. If I were to change this specific transaction would fail because I only specified that I want to send to this address. And that is done when you actually create the session, which is over here. The session key data itself, which holds 4 arguments. It's going to be the session key EOA. You're basically creating an EOA for your DApp that's going to sign on your behalf. You're passing it a token address, you're passing it a receiver address, and a maximum amount. So these are the permissions that you create on your front end and pass to your session key validation module for it to check against every time you do a transaction. And then there's just a few other pieces of data. How long is it valid for? It's 0, here, which means it'll be valid forever. You shouldn't do this in production. Make sure you actually have an end date. You just pass a Unix timestamp here, and you're good to go. And the last thing that I want to call out here, in this demo, we're saving the session key private key to local storage. This may or may not be something you want to do in production, but you have to look at the trade-offs of doing it this way versus saving it on some server. If you save it on some server, you have direct access to the private key of the session. So you want to look at the trade-offs. Do you want to keep that on the client side and let the user kind of just worry about that and make sure they don't have any malicious code running? Or do you want to manage it for them? So look at the trade-offs for your specific use case, depending on how you want to go on that end. But this is a quick run-through of the code. Now, really quickly, let's chat through stuff that you can build. So our top prizes revolve around awesome use cases with our modules. What are some things you can build? I've actually seen a couple of people come up to me asking about this already. Payment subscriptions. You can build a module that allows a merchant to pull funds from a smart account. You can actually just use even the base ERC20 contract that I have and add just additional bits of logic to it, and you can probably create this weekend pretty quickly. Automated token trading. Again, another thing that you can just build on top of the ERC20 session module that we showed, based on different market conditions, based on how much gas the gas price is, token prices, do specific token trades, or add daily limits to your spending. Replace the ERC20 token entirely with NFTs. ERC 721 NFT rentals. Create a module that allows P2P NFT rentals between users. Look at gaming modules. We just looked at like signing transactions for on-chain gaming. Kind of sucks. You don't want to keep signing every time you do an action on-chain. How can you use session keys to improve gaming use cases? Do something like creating a wallet burner factory. Allow users to create burner accounts for specific transactions. Give an account the ability to do a specific transaction and then never use it again. And if you're excited to build, let us know. We're at Biconomy. I'm at Rahat Codes on Twitter. You're not the only one who's excited. Today, we actually just passed 600,000 user operations that have been that have gone through our system. So we'd love to see you kind of like adding to that number and joining in the community who's building around Biconomy. So I'll be around all week. We have a couple of engineers who are here as well. Would love to see what you guys build.
good. Yep. Hey guys, welcome. I'm good to go. Ready to get started? Cool. Cool, yeah, thanks everyone for coming. I'm going to be talking about Hyperlane today. I'm York. I'm one of the members of the founding team at Hyperlane. Hyperlane's an interoperability protocol. We're pioneering this approach called permissionless interoperability. The main idea is instead of having a kind of service-oriented approach where you need to come and do BD with Hyperlane to get your chain connected via some interoperability protocol that doesn't compromise on security. You can actually deploy our protocol yourself, and you can bring your own security preferences. We've done a lot of work to modularize our protocol to allow people to extend it to new VMs, to new chain architectures, and I'm going to be talking through the motivation of that. So first, I'll start with some definitions. Permissionless, I think a lot of people talk about. To me, permissionless means a protocol is accessible to everyone. There's no censorship. There's no ability for someone within the protocol or some operator to discriminate against some developer, some actor, some user. And interoperability, to me, is composability amongst dApps that exist on different infrastructure layers. I think this word also gets thrown around a lot. It can mean a lot of things in software, interoperability, but in a blockchain context, this is what it means to me. So why do we care about permissionless interoperability? So if you look at the kind of trajectory of the ecosystem for the past, I don't know, decade or so, you'll see that we're increasingly using divergent infrastructure as dApp developers. We started with this payments application. It was on Bitcoin. It had this very simple kind of blockchain architecture. And then Ethereum came along and generalized this to any sort of computation that can be executed in the VM within the block. We have Near and Solana who kind of quickly followed suit. There's some other smart contract chains that would put in this category. And then folks decided, oh, actually, I'd like to push that even further. I'd like to make some generalized chain SDK or framework that gives me the benefits, the developer experience benefits of something like Ethereum, but makes optimizations kind of deep in the stack, whether it's at the consensus layer or kind of at the monetary policy layer, which allow the application to have more sovereignty. So this is where we got things like Cosmos and Polkadot, where application developers wanted to be able to control things lower in the stack and not be beholden to Ethereum validators adopting their EIPs, that sort of thing. And then in the past couple years, we've been, at least the Ethereum ecosystem has kind of been full steam ahead on this roll-up-centric roadmap. Vitalik's talked a lot about it. There's a lot of kind of scaling benefits to this approach, and there's a lot of teams here that are building towards this vision. The Optimism team specifically has kind of tried to, maybe create an experience similar to the Cosmos SDK for launching your own rollup. So that's the OP stack. More and more teams are kind of seeing the light and kind of re-architecting their applications to take advantage of some of the properties of rollups, mainly that you don't have to kind of bootstrap a security budget. You can inherit that from the L1. There's also a lot of people thinking about Plasma and sharding. Depending on who you talk to, you might put different chains in this category, but this presents a problem. And the problem is that, quickly to highlight some of these applications who are adopting these new architectures, or dApps specifically, right? We have Zora, they launched an L2 recently. Obviously Coinbase has been, I guess it's like base summer. Everyone's super excited about the Coinbase L2. And over time, what we're seeing actually is that both applications and users are migrating. And actually there's more activity on these new infrastructure layers than there is on the L1. So this is not just like something theoretical that only researchers are talking about. This is actually playing out in production. People are migrating. And so the problem this presents is we have fragmentation. Basically, that if you look at kind of the top few alternative networks besides Ethereum L1, all of these different networks, Arbitrum1, OP Mainnet, Polygon POS, CK Sync, Ronin, Avalanche Bridge, every single one of these has a different interface for interoperability. And what that means is, as an application developer, you have to reintegrate every single one of these networks if you want to be composable across all these different networks. And in a market that's kind of increasingly shrinking, or maybe not growing at a pace that we'd like it to be, it's really important that you can actually reach all of the users within the ecosystem. And a lot of users are opinionated about what network they hold their funds on, or what wallets they use that support maybe like a small subset of networks. And so even if you want to kind of adopt one of these new infrastructure layers, you have to meet your users where they are. And this is kind of the central problem of interoperability, and specifically kind of in the Ethereum ecosystem, all these new rollups popping up. And just, yeah, super explicitly, like all of these three actions that I describe up here all have separate interfaces. I think you'd be hard pressed to find a developer either at this hackathon or in the world who knows how all these interfaces work, what the kind of security guarantees are, what the semantics and capabilities are of them. What happens if your message between the chains fails, failure modes, payments, all this stuff is really complicated. And there's this crazy matrix that's ever expanding of all of the different networks you need to understand. And so at Hyperlane, we've been thinking hard about this problem, and we've been trying to figure out what's the right abstraction to allow dApp developers not to think about this, not to think about Optimism has their own bridge interface, Arbitrum has their own bridge interface, ZK Sync, Ronin, Polygon, whatever, they all have their own interfaces. And really you want a consistent application interface, right? I think we'd all like there to be some simple function that you can use, but the challenge becomes, okay, well, how do we maintain the security guarantees of these underlying bridges while having a consistent interface? And this is what the Hyperlane protocol does. So Hyperlane kind of implements this approach to interoperability. We're embracing modularity, and we're separating the transport layer and the application layer. So at the application layer, you can have this consistent interface, which is quite simple. It's basically an on-chain smart contract API that allows you to pass a destination chain, a recipient address on that destination chain, and basically arbitrary bytes. And this is available to and from every chain that our smart contracts are implemented in. Not exclusive to Ethereum. We've actually recently expanded to a bunch of other VMs. We're on the Solana VM. We're about to ship the CosmWasm implementation, encouraging a lot of people to basically implement this protocol in their own VMs, Move coming soon, et cetera. But we want this interface to be everywhere, so there's kind of a consistent developer experience. And underneath the hood, our protocol will go and choose the transport layer which makes the most sense. And not only makes the most sense, but actually allows the message recipient to basically specify their own preferences for security. So a lot of people talk about the 7-day withdrawal window from a lot of these rollups, and how it's a really shitty user experience, excuse my language. And yeah, I think a lot of people, users, have started to go around these bridges. Instead of choosing to opt into this 7-day withdrawal period, which maybe has the kind of best theoretical censorship guarantees, they're using things like Stargate and Hop and Across and take your pick, Connext. They're using these things which have different security trade-offs. And so actually users are already making these choices independent of the applications, and the applications have to basically support the pathways that users prefer. And ideally, like, applications are designed to, you know, basically like encourage this behavior rather than kind of having this like rigid, forced pathway of like, in order to use my application, you have to go through all these hoops to like bridge through the kind of canonical bridge and like, you know, do all these weird API calls, etc. So yeah, basically in Hyperlane, the message recipient can specify their own security. We call these interchain security modules. We have a bunch of off-the-shelf options, some of which basically wrap the native bridges of the rollups that I was describing earlier. So we have this for kind of all of the major rollup transport layers. But the beauty of this is we want to allow someone, if they're sending from, you know, Ethereum to Optimism, to use the Optimism bridge security. But if they're sending from Optimism to Arbitrum, you know, we can take some alternative trade-off rather than forcing users to route through the L1, take on this like 7-day latency. Obviously, there's like liquidity solutions, but again, these take different security trade-offs that maybe developers might not be aware of. So yeah, this is the core idea of our protocol. Yeah, just to kind of zoom in quickly, the security preferences that the application developer can express are actually a function of message content. And so something I'm excited about personally is like this L2 to L2 interop use case without forcing users to go through the L1, have that fast, cheap, you know, not have to worry about like interfacing with the L1 settlement period. And so we have a bunch of great designs for this that use economic security instead of like going through the fraud-proof system. Like, as long as we have a pool of stake at risk on the L1 that's basically like providing kind of pre-comps of all these rollups that are participating in the system, you can get basically like fast, cheap interop between these rollups up to whatever amount of economic security we have. And you know, people sometimes ask us, well, you know, what happens when you exceed that economic security? And the point of this interface is that application developers can say, okay, beyond this amount of monetary value associated with my message, let's say this message is hitting my protocol, and I know it's gonna, the message is associated with like, you know, $10 million. And that's super scary. I don't want to just like trust some validator that's giving me like a fast pre-conf attestation on that. I want to maybe force that to go through the slower, more secure pathway, kind of analogous to like traditional finance wire limits. You can do that. You can express that as a function of message content. So you can say, if the message, you know, exceeds this value, go and like have some sort of manual review process or veto or whatever it is, optimistic. We have all these like off-the-shelf security modes that you can kind of pick and compose. And then the other thing I wanted to highlight is that actually, like, we want people here to expand our protocol. We don't want to necessarily be the only operators of this thing. The protocol itself is implemented in smart contracts. There's a few off-chain actors that are totally permissionless. All this is configurable. And we've basically spent the last year or so kind of making this experience accessible to developers. So if you guys are spinning up your own rollup this weekend, or you know, you're experimenting with some new chain architecture, some new VM, you know, maybe it's Move, maybe it's something, you can basically deploy our protocol to these new chains without ever talking to us, without doing some like BD or sales cycle with our organization, and get the benefits of all the other networks that are already connected in our protocol. So there's kind of this nice like network effect where you now only have to do a single Hyperlane integration instead of what I was highlighting before, which is like, you know, 10 plus integrations per application developer. So yeah, this is like really all about developer experience here. yeah, I wanted to quickly highlight a few of the like applications we've built on top of this primitive. So obviously token bridging, people like moving tokens around. We have kind of like a template application and UI that's like a full stack solution for everything from like interacting with our contracts on multiple VMs. So this actually supports Solana already, but there's basically like a template repo you guys can fork that allows you to hook up this like UI and multi-VM like wallet experience to any of the chains you like and spin up a token. There's kind of a few different flavors of like token bridge you can choose from. You can do like a classic like lock and unlock bridge if you guys already have some token you want to play around with. If you want to create a new token, we can do like this kind of like native mint and burn style thing, kind of similar to Circle's like CCTP protocol. You can also bridge the native asset of a chain as a token to an Ethereum network. And so we actually did this recently. We helped launch the first SVM rollup. And actually the native asset of the SVM rollup is just represented as an ERC20 on Ethereum. And that's kind of the onboarding mechanism. And they're using Hyperlane underneath the hood. It's called Nautilus Chain, if you guys want to check it out. We also have a few other kind of like nice developer primitives for people here. I have just a couple minutes left, so I'm going to rush through this. But you can have interchain accounts, interchain queries. Basic premise here is like you can have a smart contract that holds assets on another chain. And that's called an interchain account. That smart contract basically has this like proxy that exists on another chain. We've abstracted that into a nice, simple smart contract API. Similarly for queries, if you want to do a view call against a remote network, we have a simple API for you to do that. And so, like again, this is all to try and solve this problem of like fragmentation, right? We want to simplify the developer experience across all these fragmented infrastructure layers. We'd love to see you guys try out some of these APIs. That's mostly it. I don't know if you guys are doing Q&A, maybe not. But I'm happy to talk after and chat with you guys about potential projects for the weekend. Yeah, can we take a question? Sorry? Corsesi. Cortesi. I'm actually not sure. I don't think so. Is that what VM is that? Okay. No, we don't right now have that, but basically like anything that compiled to that instruction set. We have the CosmWasm implementation, which is basically Rust, so you could probably hack together some just like compilation toolchain and deploy the CosmWasm contracts to maybe that VM. Cool, thanks so much, guys.
Okay. Is this working? Okay. GM Stylus. So, today we're going to do a workshop where you're going to be able to deploy your own Rust ERC 721. That is, we're going to make NFTs together using the Rust programming language and Arbitrum Stylus. So if you actually want to follow along and deploy this NFT, which you're going to see is pretty cool and straightforward, you'll need to go to this link. So there's this GitHub repo, and if you follow along with this, you'll be able to actually create your NFT and use it to do a bunch of fun stuff. So this workshop kind of has two parts to it. In the beginning here, while we're all getting the things installed on that GitHub page set up, so that's just like the Rust programming language, Cargo Stylus, the tool we use to actually deploy Stylus programs, and some free testnet ether. So if you're low on testnet ETH, we have that too. All of that is on this page here. So this is on the Off-Chain Labs account. There is a Stylus Workshop NFT repo, and we'll look at this together. So while everyone's setting that up, we're going to look at an example ERC 721 implementation together to try and learn a little bit more about how Rust and stuff works from a perspective of a Solidity developer and what actually working in it in an Arbitrum setting looks like. And then at the end, we'll just work on NFTs together. So, okay. So this repo is where you want to go. I'll show the link again later, but it's on the Off-Chain Labs. Just search Stylus Workshop NFT. That'll take you to this repo here. And it's kind of what you expect from a Git repo. You just clone this thing. And okay, good, you can see this. I'm going to jump into code together, but just real quick. So you're going to install Rust. You're going to install Cargo Stylus, and here's the commands for it. And then you're going to get some free testnet ether from this faucet. So you won't have to buy anything. You can just do it. Okay, so yeah, you'll just go through this repo. We hope too later that this will be of educational value, just looking at this code together. But let's do a little deep dive together with it. So I'm going to open it up in my editor. You're going to find that when you look at this NFT project, there is this source directory and various files in it. There's only a few. The first one, which will be of particular interest to anybody who's actually done a lot of work with Solidity before, is this 721.rs. So .rs is the extension for Rust, and you'll actually see as we scroll through this together that what it means to write an ERC 721 in Stylus using Rust is actually quite similar to what it means in Solidity. You'll find that every program begins with a set of storage definitions. And you'll notice that using the Stylus SDK, that is the special Rust library that Off-Chain Labs provides, you're actually able to declare the various pieces of state using Solidity syntax. So you'll notice here that this ERC 721, this is the object that implements, that actually implements the interface that provides that NFT standard. You'll notice that it has a few pieces of state. It has a mapping of UINT 256s to addresses. Those are owners of various token IDs. It's got approvals and balances and all of that good stuff, right? All the stuff you would expect from that standard. So from the perspective of somebody actually using Stylus, you just declare the various pieces of state that you want, oftentimes by just copying and pasting whatever Solidity definitions that you like into your code, and you use this special macro called soul storage for it. Definitely feel free to read the code in further detail later to really grok all the ins and outs of it. But you're just going to notice, just from a high level, looking at this together, we've got events that are declared much the same way as in Solidity. We've got errors and all of that good stuff. And what's kind of cool about Rust is the way the methods work is similar. So there's this external macro that we often apply, and that actually allows you to declare each of the methods of your smart contract and have them be exposed to the world in the same way a Solidity smart contract's methods are marked external. So when you look at these Rust definitions, for example, this name or this symbol or this balance of, right? This should look eerily similar to what you would see in Solidity, right? Well, here's the cool thing. You can actually call it from Solidity. Because under the hood, the Stylus SDK uses the same Solidity ABI, every contract written in Rust really just like looks like a Solidity contract. And I say Rust here, but of course the Stylus SDK has other languages too. And so what that means actually, by the way, is that without any modifications to a DEX, say like Uniswap or pick your favorite, right? You can actually deploy and list Rust smart contracts, like Rust tokens, Rust NFTs, whatever, to these standard protocols without those protocols having to have any kinds of modifications. So you just write your code in whatever language you like, and then from the perspective of the chain, everything just looks like Solidity. And you know, different methods do different things, like transferring the NFT around or approving other accounts to be able to spin the NFT on your behalf. That's a pretty dangerous thing, actually, as numerous exploits have shown. But the really cool part about this is like this standard, this ERC 721 standard that you're very familiar with if you've ever worked with NFTs before, can be replicated in different languages. And all that really looks like is just providing definitions for each of those mechanisms, each of those methods in Rust or in whatever language we're thinking of. And you'll actually notice that the Stylus SDK that you can download on that page has all of the affordances you would expect to have in an EVM environment. So for example, you're actually able to emit logs, and you're able to, well, you can't really do this as easily in Solidity, but you can print to the console and stuff. There's all sorts of really nice things that you're able to do, like inspect your message sender or transfer value around, have payable methods, a lot of great stuff. So I strongly recommend reading the ERC 721 file under the source directory for a bit of a nice parallel side by side. But there's actually more that we're able to do because this is Rust. So if you actually go to the art.rs file, you're going to see that together we're going to make some NFTs here. So because this is Rust, which has like really nice low-level types and stuff, you can actually do things like import an existing image library and create PNGs from your application on-chain. That's right, the NFT that we're going to be making today is entirely on-chain. So there's no like hash that it stores and some other website that's trusted presents the data or whatever. All of this stuff happens on-chain, is fully generative, and has all that censorship resistance, all those great properties that you would have of a fully on-chain product. And what's cool about it is instead of having to like say in Solidity, right, like do a bunch of like low-level assembly code, you just use familiar programming paradigms and like nice high-level constructs when working on your stuff. Okay, so from the purpose of today's tutorial, and you'll see this also on the GitHub repo, there is a function that we're going to modify together to create new NFTs. So there's this generate NFT function, and it takes as an input the token ID. So that's like which, every new NFT has a unique identifier, and that identifier you can use to generate different kinds of art. And you'll see that in this example project, you're able to generate an image and then make modifications to that image in a procedural manner. So here we're drawing a gradient, we draw a line on it, then we draw another line that goes from this point to that point, we draw an ellipse, and let me just actually show you what that looks like. So what's really cool about this is because this is Rust and you have access to the console, we can actually print our NFT out. So take a look at this together. Those steps that I showed earlier, we have, well, from the top left corner to the bottom right, we have the gradient line. This was that draw gradient. And then we have various lines to make the eyeballs in this picture. And then the ellipse to make the smiley face. And what's so cool about this is it shows that the future of actually like working on blockchain applications is one where all the familiar tooling that you already have is much more easily accessible, right? Like if we're able to have languages like Rust, we get test cases from Rust and stuff like that. And I'm actually using that to generate different versions of this NFT. You'll notice that in the code, right now the only way it varies is the color it uses for the smiley face. But hey, you can notice here that with different identifiers, I can each time print this out. So what's really cool about that too is it means that like debugging and working on your NFT is actually really straightforward because you actually have access to like a really nice console where you can like do all of the things that you'd expect in tracing and all of that good stuff. So you can just use a simple command, which you'll see in the GitHub repo, to print your NFT out. And by the way, here's actually a website that's showing them. the internet's kind of a problem, but I'll get it to reconnect. But the cool thing here is like when you guys using that GitHub repo deploy your NFT, it's going to show up on this web page. So if someone wants to draw something and edit that code together, you're going to be able to actually change what's on this screen. So that's kind of fun. And how this is literally working is it's just reading the blockchain, looking for any deployments of this contract. Let me actually show you what it looks like to deploy it. Okay, so assuming I have internet, we're going to make sure. You actually have this really cool tool called Cargo Stylus that we use. The installation instructions are there, but it's really simple. It's just a single line. But what Cargo Stylus lets you do is, well, you can check and deploy transactions. So, you know, when you're programming your code, it's often good to like run test cases to make sure things work. And what this Cargo Stylus check tool does is it will actually go and make sure that if we were to go deploy this to the blockchain, that everything works. And if you go and you've made some changes to your NFT, you can run. Well, actually, I need a private key file, so let me find that previously in my history. You can actually run Cargo Stylus deploy and then point that to a private key somewhere. And it will then go and deploy and then activate your NFT on chain. And what's so cool about that is in just like one little step, right, using these very familiar Rust tools, Cargo is like the standard Rust tool. You know, we're able to, with Stylus, have just some minor extensions, and then suddenly, bam, you've got all this great on-chain goodness. So I think our goal today is this. Now that we've kind of like taken a look at various, you know, we've looked together at how the code works. I invite everybody to take a big, deeper dive or whatever. Let's actually edit these NFTs together. So, you know, we can just take this function, this generate NFT function, and make whatever modifications we want. So for example, maybe I want to add another line, right? All you got to do that is in your editor, you know, you add another line that says line, and then pick another position to start drawing from. So maybe I'll start from the coordinate 810 and draw all the way to the coordinate, I guess, 15, 16. That sounds fun. That'll be nice and diagonal. And you can pick what color you want to draw it in, right? So maybe I'll pick another hex color. Let's do pink. Let's do actually a nice stylus pink. So the stylus hex code is E3066E. So that should draw a pink line if our reasoning was right. And so, well, let's just test it. Let's just make sure NFT works. And hey, there it is. There's our pink line, right? And what's so fun about that is there's this like really nice like iterative feedback you can do when you're working in your work in Rust. Like, don't get me wrong, in the Solidity world, we have hard hat, we have, well, truffle sunsetted, but like you have all this like great stuff, right? And, you know, you'll actually find that like printing to the console or doing things like that are kind of high friction, you know, it's not really super well supported. And you have to use these kind of awkward function signatures. Well, in this paradigm, you can just like do all the familiar stuff that you're used to. And by the way, that includes with like debugging and all the familiar tools. We're soon to release the ability to do GDB on the blockchain. So you'll be able to like, when you're in the middle of your smart contract, if something goes wrong, you might want to like go jump in and see what exactly went wrong. Well, you can then fire up GDB. This is a very common debugger that people use in Rust or C, et cetera. And just go see for yourself what exactly went wrong and step through it and use all that without having to like learn new tooling and stuff. Okay, so I think since we've looked at this together, let's we're just going to go around the room and help anyone who wants to set up an NFT do so, and yeah, get these deployed and shown up here. So that's part one of the talk. Let's collaborate. Here's the link if anyone wants to like, you know, follow along, do all that. It's good stuff. somebody deployed something. Nice work, guys. Anything you deploy is going to show up here. Yeah. All right. Thanks, everybody. So this has been Making Stylus NFTs in Rust. We're going to, yeah, so as you've noticed from this, you can basically implement any kind of standard that you're imagining. So Rust or C or C++, these can be used to generate the stuff that we currently have in Web3. One reason, by the way, you might want to use this, oh, somebody's generating a new one. One of the reasons why you might want to use this, Rust smart contracts are 10 to 100 times cheaper when it comes to computation. So if you're doing generative art or making really cool and expressive things or powerful financial apps or whatever it is, doing it in these languages and having also this just awesome tooling and stuff isn't just like nice in terms of DevX, it's also nice in terms of fees, and price-sensitive applications are going to care about that. But that's the end of this. We're going to have a booth over, or we have an Arbitrum booth over out in the main floor if you want to talk more or have any questions. Thanks so much, everyone.
Cool. All right. Thanks so much for everyone being here. So my name is Tom, and I'm from Wallet Connect. And today we're going to be going through building dApp notifications with Web3 Inbox. So yeah, once again, my name is Tom. I'm a developer relation lead at Wallet Connect. So a bit about myself. Around 5-6 years ago, I was in community doing that kind of things. I was working on meta transactions, but it was a bit too early for those days. And then I switched into mobile engineering, and here I am now. So excited to be here, and look forward to kind of talking about dApp notifications. So for those who don't know or do know about Wallet Connect, I think you might probably famously know us for like QR codes, but we do a little bit more than that. So the simplest way for you guys to kind of understand what we do and outside of QR codes is a protocol that enables any two parties to connect. It seems kind of simple, but it actually means quite a lot. I guess in Web3, it's like dApps and wallets. Those are the two main parties. There's the wallet, which, you know, there's quite a few, and then there are many more dApps and the use cases. And I think that's why us hackers here are here to build better use cases for the world, right? So we're secure, trustless, open source, and chain agnostic. So we started open source day one. It was literally just a one-man team and a project, kind of like what spun out of a hackathon. And we're here now, and till the day, we still stick to our like open source ethos. And then the last part, most importantly, is chain agnostic. A lot of us will probably be hacking on EVM stuff today, and that's really cool. Like I started in EVM, but there's a lot more that we can do. And I would say like DeFi Summer, like NFT Boom, and then we had like chains like Solana, Cosmos, Polkadot, all these cool chains coming out. And it's something we started to pay attention a lot more to. And chain agnostic is kind of what we stand for, like build for the masses, let two parties connect, and we don't care which like blockchain nation that you really like. We're pretty agnostic to that one. So that's what we like to support and we'd like to stick towards. Cool. So I'm just going to go through what we do, and then I'll be getting right into the workshop. So we have 3 verticals at Wallet Connect. It's Web3 Wallet, Web3 Modal, and Web3 Inbox. So Web3 Wallet, pretty self-explanatory. It's pretty much, we have around 400-500 wallets that are in our Wallet Connect registry. So under the hood, once again, we're not a wallet. I think you guys see options of MetaMask, Wallet Connect. We're not a wallet. We're a wallet infrastructure company and dApp infrastructure company. And Web3 Wallet is the thing under the hood that's powering most of the wallets that you use today. So that's if you guys are interested in being a wallet developer. Just as a hot tip, being a wallet developer in this space or knowing how to make wallets is actually really advantageous. I learned a lot more building wallets for myself and then going into the dApp side. So that's some alpha or whatever you guys want to do with it, but it's really interesting to know how wallets and dApps work as opposed to just learning about dApps. Web3 Modal, this is our flagship Connect Wallet button. So you might have seen that, and part of that is the one that pops up the QR code. So that's probably the one that you guys have seen the most, and it's probably the most famous one that we use. And today we're in alpha on Web3 Inbox. So this is some cool stuff around notifications, soon to be chat. And it's really around communication. Like our thesis is really protocols communicating. So dApps, wallets, and whatever happens in between. So we're really excited to be talking around that. So I'll go a bit deeper into this. And bear with me, I'll be getting to the tutorial shortly. So Web3 Wallet SDK. So connecting your wallets. You might have seen this on several of your wallets. You're like, hey, this dApp wants to connect to your wallet. You press connect. Whether it's a Rainbow wallet or anything else. Ethereum, we once again chain agnostic, so you're pretty much base, all these other cool, L2s and EVM compatible chains, and even like Solana and stuff, like you can switch those networks. So it's a one-click login, 400, 500, 600 wallets out there. Most of them support Wallet Connect. And then the last part you might see on the little corner there, it's called domain not verified. Check if it's legit. So I think a lot of phishing can happen in this space, right? Like, I think, what was it, Mark Cuban or someone just got phished. So, like, sorry that happened to him, but, like, we have to take better, like, general security preventative measures. And recently, we launched this thing called Verify API. So it's a simple registry that we work with. It's just a starting point to check, like, say, for instance, uniswap.com and eviluniswap.com. Like, how do you know the difference? Like, how do you know that this example.com is legit? So this is stuff that we've been working on, and I think the space in general is like moving really well with how do we stop like phishing attacks? How do we prevent like and enhance our security experience, right? Cool. So that's what Web3 Wallet is. If you want to be a wallet developer, check this out. So Web3 Modal, this is the one that was previously kind of like the whole QR code thing. We've abstracted a little bit more. This is our V3 version and just kind of coming out in beta. And soon enough, like we got some other cool things around email sign-in and also this other technical one called EIP 6963. So for those like who've done dApp development before, there's this like really like annoying thing called window.ethereum. And that's what everyone injects into, right? So everyone tries like on this list here, if you're like a browser extension, as a dApp developer, you literally fight for window.ethereum and you overwrite each other. So what we're actually shipping very shortly, maybe like next week, is EIP 6963. So multiple injector wallets can be recognized, and then you can like not fight for window.ethereum anymore. So you can do like Phantom, you can do Brave Wallet, you can do Xerion, Rainbow. Like you can actually work together. And I think it's like maybe it's only a thing that developers care about, but I think it's a UX issue, right? Sometimes like some of you might have a few extensions and you have to fight for whose extension works for you, and it's really annoying. Like you have to disable it and stuff like that. This is some cool stuff that I hope you guys can kind of look out for. So we're working a lot on the whole dApp side of these things here. Cool. And then the last part that I'll be going into a bit deeper today is around Web3 Inbox SDK. So I'm going to go into more the use case and why we kind of built this, as opposed to just working on dApps and wallets. But we need to know, like, we need to unlock better use cases for like what we do today. And I think our thesis is really around communication, like chat, notifications, like going through this like example list, right? You can know when your NFT's going, your snapshot is going, like all these on-chain events. If you can know like what's happening, I think that's pretty cool, and that helps you a lot more like feel like a Web 2 application, like kind of what you're used to with Instagram and all of this. So trying to bring in more of a realistic user experience and then being able to use that in Web3 is kind of what we're striving for. So there's some cool stuff that's coming out. And this is just kind of like this is just a web app that we built on top of it that uses our SDK but shows what's up. So think about Gmail, right? Like you have all of your notifications come in, but think about if you had like a Web3 specific Gmail, which supports all your notifications and all of that. You open it up like, oh crap, like, you know, crypto trader 123, like, you know, shorted ETH, right? And then you're like, you know, these things, like, that's just like one example, but DAO snapshot voting, all these other cool things that you could probably check out, like PancakeSwap, Mirror, Lens, like things like that. So this is what we have shipped in alpha, and I'll show you an example of that shortly. Sick. So you guys want money, right? So that's what we're here for. We got 20K worth of bounties, and we got 5 tracks, which I'll go through. So Web3 Inbox, that's the one we just came out in alpha with like a few days ago, and that's what we want you to hack on. So that's 8K worth. We have documentation on it, so check it out later. Web3 Inbox came out in beta as a new turn, bit of money there. And of course, we started in the roots of mobile, right? Like, it's actually, so if I actually tell the genesis of Wallet Connect, it was kind of like WhatsApp, whenever you connect your QR code via WhatsApp to your desktop thing, right? And we only existed in MetaMask browser wallets in 2017, 2018. So it's kind of a boring experience. And then we kind of took that experience to be like, how can you kind of like use QR codes and like relay networks to try and connect? And that was the whole genesis of Wallet Connect. And this is where we're here today. And so we don't want to like forget our roots. So if you want to go hack on mobile, we've got bounties for that. Innovation, go wild, man. Men and women, everyone else. So like you can go build anything like AA, account abstraction, passkeys, like ZK stuff, like whatever you guys want to build on, any cool stuff you want to build on, as long as you use an SDK, go for that. And then pool prize. So anyone who uses an SDK, top 10 of you get $100. So not bad. 20K worth of bounties. Come see our booth later on, and that's what we're here for. Cool. To get into the meat of everything. So the next frontier of web experiences is kind of to do with wallet messaging. So dApp to wallet notifications and wallet to wallet messaging. Like we really want to think about this. How does this help unlock the future of things? I think there's one slide. Yeah, let me go through here. So we've thought a lot, like we've spent so much time on connecting wallets, and what does like connecting a wallet actually mean? So I've thought a lot about this, particularly because I was spending a lot of time developing wallets. And this is kind of what we have. We have financial reading and writing. We have NFT reading and writing. We have identity, like cool stuff with ENS, Lens, decentralized identities, DIDs. Transaction simulation, like security stuff, like Verify. And then we have multi-chain. So this is, maybe I'm missing a few things, but I feel like that covers like what is dApp development. Right, and I think we can do better. Like, we have to think a bit more around tomorrow. Like, don't just build some random like staking app or whatever. Like, let's think of like how can we extend that use case towards more things, and that's what we're like really trying to think about with Web3 Inbox. So, like I said, the left-hand side represents kind of where we are now, and like let's try and use this hackathon as like an ideal way to like think more around communication. How do you make this app or developer experience or user experience feel more like web, like a good standard Web 2 product? And this is like going beyond just sending a transaction or an NFT, right? So our thesis is really around communication, right? So how can you start doing notifications around user engagement? How can you let each other know like, hey, like this kind of stuff is happening in DAOs, like this kind of stuff is happening, you know, on the NFT marketplace. Like, how can we extend this, like, use case to a bit further and then just keep getting better from here? So the more utility, the more interaction, the more times you end up using dApps and wallets, like, that's a good experience. Like, right now, like, I still interact with as many dApps as I can, but it's hard. Like, we need to have it more natively. Like, we need to make it feel like, oh, crap, like, I actually want to use this dApp because of this X use case, and coming back to this cycle loop. And the last point I kind of want to go about, and I'll get into it's a bit theoretical, but I'll kind of get into this, is like wallets started in 2017 as just mainnet and testnet and transactions on ERC20. Like, we've come a long way, but I feel like, in my personal opinion, that wallets kind of represent a sense of identity and what you can do with it, right? It's not just because you have 0x123 and you do transactions. It's more like, who are you as 0x123? What actions have you done? And like, what does that represent out of you, right? And I think like cool things like token-bound accounts like really represent this. Like, you can like merge NFTs into like who you are and resemble what you are. I think data is like the biggest kind of cool hot topic around now. Like, maybe it's like the whole AI hype, but like AI, like people like trying to go through this data and like figure out who are you. And I feel like that's kind of coming towards like your wallet 0x123 isn't just a financial list of what you've transacted, but it's kind of more of your identity. So kind of like maybe thinking about that kind of might help along with the hackathon of things. Cool. So I think you guys saw some of this stuff, so I won't go too deep into it. So really want to kind of just incentivize and also just think a little bit more about how can we do different use cases? How can we get more, I guess, willingness and wantingness to actually come back towards dApps and wallets? And I think that's really missing. Like, you might use the dApp like once, like, haha, I got like 3%, like, you know, APR, like, you know, back then it was a bit different, but we're in a bear market, so we have to think about different ways, right? Cool, so this is what we've been doing. Like, imagine on your phone that you end up actually seeing these kind of things, like, oh, like, instead of having to go back into your app and being like, oh, I actually got my reward, just be like, open up your phone like you would with your Instagram notifications and things like that, and really just be like, oh, like, cool, this happened, right? It's all on chain, things are happening, so like listen to it, and that's through notifications, chat. Sick. So this is more of a GitHub template for those who are interested to look at. It's just like a huge README and a template. And what I'm going to be going through is like, what does that end up looking like? So I think if I go this way, sick. All right, so this is what that QR code ends up helping you create. So very simple, like very simple UI. So I'm going to go through here. I'm going to connect to a wallet. I use MetaMask. And what it does, so this is Web3 Inbox. And you have to sign this thing, and it has this URI called DIDs. So this is actually decentralized identity stuff. So it's asking for your public key and like kind of requesting that. So we have followed the ethos of being decentralized around this. So there's some cool stuff. It might be a bit complicated, but it's trying to really approach like decentralized like networks around things. Cool, I'm 0x87, whatever. And then I'm going to use this app and subscribe through Web3 Inbox SDK. So we got some things here, which I'll go into a bit later. So subscription, it's a bit more of the technical stuff, so like you can kind of check that out a bit later. But essentially, this is just, you'll come into the code base a bit later. So the cool thing here is you just saw it flash green. This is actually mining, like sending in a notification when a block was mined. So kind of think about like that pancake swap thing that I just previewed before. And it kind of just like represents, oh, like things are actually happening on chain. And then also sending a test notification. So it was, I don't know why I wrote Tom is the best or whatever, but you know, it's just a representation of how to send like test notifications like on chain. These are some preferences, like kind of types of transactions that you might want to send, and you can set the params yourself. And yeah, so I think I'm going to be, as this moves on, showing other things. But I'm also going to show you our app. So this is just like me running this stuff on localhost, right? And what I want to do here is this is like our app that uses our SDK to pull stuff. So think of this as your Web3 Gmail or Web3 inbox, right? So you would be exploring apps, same address, you explore apps, that's another one, but I subscribe to the example I had before. So then I subscribe to the topic, same thing. Cool. And I think I'm going to be showing this like side by side, right? So a new block just got mined, and that represents it in the app, like in your Gmail app, and then you just send another one, and it's like in sync, right? So these are all happening on chain, and it's really cool of like how it's been going. So I won't be doing a live demo because I think Wi-Fi and all of that can happen, right? So yarn add, Web3 inbox, core, just add in some things here. But you can use this one, like we just use the template on GitHub and then you can immediately like, how do you call it? Like get all the packages and everything. So this is for those who are really interested in Web3 inbox. Sorry, I'll stay there for 5 more seconds. Sick. All right, so as you kind of need some secrets and public project IDs, etc. Simple stuff. Notify API secret that allows you to subscribe to our service and use our network. So that's simple stuff. This might be more familiar on the kind of like authorizations and sending through. And here, this is just a JSON stringify of that. You would send a notification. I'd send in some params of title, GM hackers, enjoy hacking on Wallet Connect. You can put on icons, so you might have seen that block on Ethereum, like these things here. So that's that. This was just a representation of just like a callback, and also we wrapped it in like hooks that you can use in like React. It's primarily just for JavaScript for like this hackathon, but we've got like our Swift team and our iOS team and all of that, so we'll be extending that shortly. So that's kind of what like the React hooks looks like. In terms of time, whoops, I'm not ready yet. I might just quickly show you guys what it kind of looks like again on code. I'll zoom in. All right, so apptxx, this is the project ID that we just saw. I'm using WAGME, so that's a pretty cool library you use, similar to ethers.js, and essentially just wraps it, right? But the meat of it within the template, it's a bit verbose, but we've kind of like put it as simple as possible. So using all of these hooks up here, yeah, all of this stuff here, it's just like we've made a simple hook system so that kind of if you're used to WAGME or just general React and JS, like it's just much easier to use. So Web3 inbox SDK hooks, subscribing to notifications, getting your account, signing messages, and then the one part here. So this was the sending test notification that I showed in that screenshot before. So you can alter this and be like GM hackers, like ETHGlobal. You know, once again, I'm not going to live code. But anyway, so that's kind of the things that you can do. This was the one that represents the block notifications that you guys saw before, the one that's recurring every time a block is run. Similar concept of sending notification on new block, Etherscan, getting that. So you can easily run events on chain, get everything that's being incoming in. So it's pretty cool. So cool. So thank you very much for attending. We'll be around the corner at Wallet Connect at the booth there. Website, docs, GitHub. We're also hiring. I believe we have JS engineers, Rust engineers, data engineers, and a few others. So for those interested, feel free to come check us out, talk to us about anything. 20K of bounties worth up for grabs. Cool. Thanks, everyone.